And then steps for writing a Turing machine from Java code. See this link here? I made a one-pager. Here's my one-pager. Oh, can you see all the way to the bottom?
Yes.
All right, so let's, in fact, I typed this in to the test. So this is part of the test. And let's read through it together, and then we'll do an example. And I have various examples that we could choose from. One of the examples that people wanted was to doing the shifting forward example. So we could do that example. So anyway, here, what is the question you're going to have to ask on the test? Is above this is some Java code, which I'm not telling you right now. I'll tell it to you tomorrow. Above it is some Java code, and then the first question is translate this code into a Turing machine transitions, right? So now here I'm reviewing how to do it. All right. So the first thing you do is you tell me which is the start state. And after you tell me the start state, there's only one thing left that you have to do. All right. You have to define the delta transition function, right? And what is delta? I'm not sure you can see this can you see this delta way on the bottom?
Yes.
All right.
Yes.
So what is the delta function? It tells you what state I'm currently in, what character I'm currently looking at, right? That's the table, right? It's a table which says what state am I in, what character am I looking at? And for each entry of the table, you have to tell me what will the new state be, what character to write, and what direction to move the head, right? Does everybody understand that? That's what a transition function is. And your only goal in this is, other than telling me the start state, your only goal is to fill in this table. All right? And how are we going to fill it in? We're going to fill it in big blocks at a time, right? Big sections. We're going to take sections of this table and we're going to fill them in simultaneously. And why do we do it in big blocks? Well, because there are going to be lots of states and there's going to be lots of values. And so it's a big, big table. And if you had to fill in the entire table one cell at a time, you would not finish for a while, right? So we want to fill in the table fast. And that actually has this added bonus that that you get more understanding, right? You get more abstraction. All right. So so let's go through and see, how do we do it? Well, the first thing you do is, I'll tell you right now, I got lots of lines of code. So one thing about this example is it has more lines of code than I'm normally giving you on assignments. So that's why I partly think, normally I have a short Java program and then a second question, but this is a pretty long Java program. So maybe I shouldn't give you a second question, but that's where I'm still. It's a long Java program, and I'll tell you what it does. It's just insertion sort, right? So you should know what insertion sort is, and I'm going to give you 33 lines of Java code. And so what are you going to do with these? You're going to, for each line of Java code, you're going to translate that line of Java code, really starting from there. You're going to translate it into Turing machine code, right? And so how do you do that? All right, so now we're considering a particular line of Java code, right? And so what do we need to do? Well, I give you loop invariants, right? What is the loop invariant? Loop invariant is the statement at a particular point in the code that tells you everything that should be true at that point in the code, right? It tells you, describes the data structure, right? So So when you're sitting at that line of code, especially if it's right out of loop invariant, you need to be able to say, you read the loop invariant, and you want me to tell you the truth is, I give you this all this Java code. Do you have to understand all the Java code? No, you don't actually even, to do this question, you don't have to understand the Java code. All right, so if you get into a panic that you don't understand the Java code, then don't panic, right? Because you don't need to understand it if you don't want. But let's go to the line of code right after the loop invariant, and the loop invariant tells me what's true in the Turing machine, right? It's going to tell me, oh, you have various variables. Maybe I have a variable P and I have a variable Q, and it tells me basically what values are on the tape, right? It tells me various things about the state of the Turing of the Java program at that point in the code. So you know that, and so what are you going to do is you consider what's true here, and then you think, well, what's the code going to do going forward? Well, there's some cases. Maybe if my value of P is less than, C is going to be the value that's on the tape, and P is going to be some variable within the Java code. And maybe there's some cases, right? So the hint is, think about what the cases are, and we're going to build a block in our table for each case, for each line of code, and for each case, there's going to be a block of code in the table. All right. But there aren't going to be that many cases. Maybe there's a case that this is less than this, and a case, or maybe there's a case that's bigger, and then there's a case, maybe I'm looking at a blank, or maybe I'm looking at a character, right? There's never more than 2 cases, all right? So given a line of code, there are going to be at most 2 cases, and for each case, we're going to build a block in our table, all right? All right, so now we have a case in mind, right? We're here, we have a case in mind, because we're doing for each cases. And so then what do we want to do? We want to say, well, given that I'm at this line of code and the loop invariant's true, and given that I have this current case, what is the range of my variables, right? What are all the values that P might have and Q might have? And let's call the values P prime and Q prime. And let's write down, hey, P prime is between da-da-da and da-da-da, and Q prime is between da-da-da and da-da-da. And maybe I know that P prime is less than Q prime, right? What do I know, right? You write down the range of these values, right? So that's what you do in this thing here. You specify on your test paper, you say, I'm now doing a particular line of code, and I'm now doing a particular block, a particular case. And for that line of code, in this case, I can specify the range of values, right? And now let's pretend we have a particular value in this range. The particular value is maybe P has value Q prime, and P has value P prime, and Q has value Q prime, all right? We have particular values. So when we have those particular values, then we can say, what state are we in, right? So write down the name of this here. This is just the name, right? Because the Java program has these variables, but Turing machines don't have variables. Turing machines don't have lines of code. Turing machines have states. So you need to know that a Turing machine only has states. And the state, you can give it any name you want to give it. So I'm going to pretend I'm in a particular state. And down here, written there, is a string which tells me the name of the state. It'll tell me what line of code am I in? Well, we're working on a particular line of code. It'll tell me the values of the variables. Maybe the variable P has the value P prime. Maybe Q has the variable Q prime, right? You have various values that tells you what the Turing machine knows, right? The Turing machine, what does it know? It knows that it's in a particular state, and that knowledge is written on Pooh Bear's blackboard. And so what's there? What's written on Jakuberry's backboard, we write down in the name of the state. So we write down what we know. The name of the state tells us the line of the code and the values of the variables. Right? Does that make sense? All right, so now we know what state we're in. Then we want to say, well, the Turing machine, not only is it in a state down here, it's in some state, it's also looking at some character on the head is somewhere, and the head is looking at some character. So there's some, let's see, denote the character that the head is looking at, right? So here I'm saying, and then, well, do we know what value we're looking at? Maybe I know that it's between this range and this range, or maybe there's a case where I know it's a blank, or maybe I know that it's bigger than P prime, right? I know something about, because I'm at this line and I'm doing a particular case, I know something about the range of C's. So write down what values C might have, right? So, okay, now, again, pretend we have a particular value of C, right? Now, because we know, we got a particular value of P and Q, we got a particular value of C, we got a particular case in mind, right? We should be able to go back to this Java code, and run the Java code. Just run it, bum, 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 bum. What does it do? Oh, it takes something from the tape and puts it in a variable. Oh, it stores something in the variable. Oh, it allocates new memory for a variable. Oh, it disallocates memory for a variable. Oh, keep running the code. Run the Java code until what happens? Until the head moves. Because when the head moves, then you have to do a delta transition. All right? So run it until the head moves. And here I said, oh, look, it's scary. I have 33 lines of Java code. Well, you're not going to have to do all these lines, because when you start at maybe line 1, it's going to run up for a while until you move the head. So some of them you kind of get all in one go. So you run the Java code, right? And you keep running it. Here we're running it until the head moves. And when the head moves, then say, now, what state is your Turing machine in, right? You're going to say, now, I'm going to be in some new line. Well, if I was in line 1 here, well, maybe I ran it past line 1, 2, 3, 4, 5, 6. And now I'm in line 6. Right? So I'm now in line 6. Oh, and what are the values of the variables? Well, the variables did have values, P prime and Q prime. And this told me what values they did have. And I ran them for a while. Now what variables do I have and what values do they have? Right? So you write down what the Turing machine now knows. Right? And that will be the next state. And so here I'm just saying, note, line equals new. This tells me what line the Java program is. Variables new, this tells me the new values of the variables, right? Because we ran code for a while, and so we now have new values of the variables. So write them down here in the state, right? And then, okay, next, just before you move the head, right? We ran the code until you're going to move the head. Just before you move the head, you write a new value, right, into the tape. So I'm letting C prime be the value that is going to be written into the tape. See, here it is down here, the value that gets written into the tape. Now, let's be fair. There are two sort of situations. Maybe it was the same value that was there before, and you don't want to change it. So a Turing machine requires that just before it moves the head, it writes a value. You have to always write a value just before you move the head. So one option is to write the same value that was there before, right? If you're reading, say, C, then you write C and you don't change the value. Another option is you have a new value, right? The Java code tells you write some value into the tape. And if you're writing some value into the tape, then we hit the needs. What is the value I'm writing into the tape? And here you write that value into the tape. Now, one thing, let me tell you that you cannot do, right? This is bad. Suppose the Java program tells you, write the value P into the tape, right? P is a variable, write its value into the tape. Suppose it tells you to do that. Can I put P down here? No. Why can I not? Well, because P doesn't exist. The Java program doesn't exist. P doesn't exist, right? So if you put P down here, then I'm going to tell the marker to take away all your marks, because that convinces me that you do not understand that there is no Java program, right? So what do you do instead? Well, suppose up here, I'm in this state and I know that P has the value P prime. Well, what's P prime? P prime is just an integer that is a value that's in some range. Remember, we said P prime is in some particular range, and we're now talking about a particular value of P prime. And we're filling out this entry of the table where P prime has a particular value, right? So if P prime has a particular value here, then what I write here is P prime. Everybody follow that? So then the Java program, when you ran it until it moves the head, so you know how it's moving the head, whether it's moving left or right. So that's what direction is. And then, so what do you write on your test, right? You say, hey, I'm considering this particular line. I'm starting at this particular line of code. I have a particular case in mind, and hence I have a particular range of values for my P prime and my Q prime, and I have a particular range for my C, and then I'm going to assume for those particular values, I'm going to assume that I'm in a particular state and I'm reading a particular character, and then I fill in the table entry that says, if I'm in this state and I'm reading this character, then I go to this state, I write this character, and I move the head in a particular direction. Right? Does that make sense?
I'm a little bit confused as to how you said that if P prime has a specific value, instead of C prime, we write P prime. I'm confused. Why is that? Why do we write P prime exactly? Like, why is it because it has a specific value that we change it?
All right. So this delta is a table, right? It has for every state of it has a row of the table, right? And what's here is simply the name of the state, right? And this is a character that might be read from the tape alphabet. It's a character that might be on the tape. So the rows, the columns are there's a column for each value that might be read. So what's allowed to be here is a state name. What's allowed to be here? A character. And then what are you allowed? Now that indicates, now we have a particular entry of the table, right? We have a particular state in mind. We have a particular character we're reading in mind. We're able to fill in that entry of the table. And what are you allowed to put there? Well, you have to put three things. You have to put the name of a state. It's just a state with a particular name. You're allowed to put a value that you're going to write into the cell, and you're allowed to state a direction, right? So this is just type checking. If you write, what is C prime? C prime is some value that we've indicated. Maybe C prime is P prime, which is some value between, maybe P prime, maybe I'm specifying a range here, P prime is between 0 and 9. So what is P prime? P prime is a number between 0 and 9, right? And so I can have P prime here because what am I allowed to fill into the entry of the table? I'm allowed to enter what value is going to be written. That's going to be a value between 0 and 9, right? But P, what's P? P is a variable in your Java program, and the Java program may be able to say, write the value that's in P prime into your cell. But the Turing machine doesn't have a Java program. In the Turing machine, P doesn't exist, right? The only place P exists in the Turing machine is that when you name a state, one state I might name is I might say line equals 5, P equals 7, right? I have a state which says line equals 5, P equals 7. And if that's my state, then what do I write here? I'm going to write 7 on the tape. And if my state is line equals 5, P equals 8, then I'm going to write 8 here on the tape, right? So we generalize that by saying, let P prime be any number between 0 and 9. And if I'm in the state line equals 5, P equals P prime, where P prime is between 0 and 9, then I write that value P prime 0 through 9 onto the tape. Right? Does that make sense?
Yes, thank you. But
and we'll go through an example.
Yeah, please. Like if we go through an example, then maybe all the steps will be clear.
Yes. One last thing here is here's my other hint. Here I have a hint that says I do it for 12 blocks. So you come up here and I say, oh, I got 33 lines of code and I got these various blocks. Well, if the number of times in my proof that I say delta, number of times I do that is about 12. So why did I tell you this? Just to let you know, if you're doing it 66 times, you're doing too many, right? It's going to be about 12. What do I mean by about 12? Probably more than 10 and less than 15, right? All right. Oh, here's my other hint. Let me do this other hint, and then we'll go through an example. Here, I'm saying generally the state changes every time you move the head. So remember what I said is you run the code until the head moves. But once in a while, you think, just aesthetically, I'm going to want to not move the head. I'm going to want to keep the head in the same place. So it's okay once or twice to say, I'm not moving the head, I'm keeping it in the same place. Generally, when I do that is when there are two cases, and in one of the cases, I move the head. In the other case, I don't move the head. So then what I do is in the one case, I move the head. In the other case, I do a stay so that it makes the code flow better. Everybody good with that?
Yeah, sure. I just have one question. Sorry,
No.
I'm confused. States and tapes.
What and what?
States and a tape. I'm getting them confused. What's the difference between a state and a tape?
All right. Well, let's push this button and this button and say what is a Turing machine? What is a Turing? What is a Turing machine? Turing machine. All right. Oops, do we have a Turing machine somewhere? Here. Oh, no, that's not a Turing machine. Let's find us a Turing machine. All right, so this is a Turing machine, right? We know a Turing machine has an infinite tape and has a bunch of states, and the states have names. But really, what's a Turing machine? It has a set of states, and if you're in Eric's class, he names them Q1, Q2, Q3. But I'm going to give them nice names. All right? So there's a set of states, and there's a tape alphabet. Here, the tape alphabet is 0, 1, and blank. But maybe the tape alphabet is 0 through 9 and blank, or maybe it's 0 through D and blank. Right? I can tell you I'm going to tell you on the test what what I want your tape alphabet to be. So this table is going to have a row for every state, and it's going to have a column for every character of your tape alphabet. And what do you need to fill in? For every cell, for each cell, you have to tell me what the Turing machine is going to do. So, for example, if I'm in state Q1 and I'm reading a 0, the head is on a 0, then what I want to do is I want to change the state Q2. I want to write a 0 on the tape where the head is, and I want to move my head right. Right? Does that make sense?
I still don't get. Sorry, I still don't get it.
Well, what don't you get?
I don't get how we determine what the Turing machine does from the table.
All right. Well, your goal is to fill in the table. So what on the test, what you'll have the following jobs. Your job, really the main job you have is to make this table. Right? So how do you make this table? Well, you're going to have to decide the names of all your states. Right? And then you're going to have to look at the test question and find out what the tape alphabet is. And so along here, you're going to have an entry for every character in your tape alphabet. And then for each guy here and each guy here, you're going to have to tell me 3 things. You're going to have to tell me if I'm in this state, and I'm looking at this character, then what state do I go next? What character do I write? What direction do I move the head? That's what a Turing machine is. Right? You understand? This is the bottom level of abstraction of a Turing machine. Right? What I'm trying to teach you here is how to move between layers of abstraction. Right? Is a Turing machine exciting in its own right? Yeah, I don't know. It's kind of cool that for every computational problem, there's a Turing machine like this that can solve it. That's kind of cool, right?
I had it. Oh, sorry.
Yeah.
Like on your example, I think someone else was asking about it too. So I'm still confused about why we can say like C and then C prime, because like I understand. Oh, like can we go back to the
that whole list of rules? Okay.
Yeah.
Well, why don't we hold that in our head for a minute and go to do a new example?
Okay, sure.
All right, and when we do the example, we'll see where we're doing the steps. And if something frightens you, then when we go through the example, holler when you don't understand, and we can always go back to what I was describing. So let's hit this button and this button. Nope, that's the wrong button. This button and this button. There we go. And now, which example we were going to do? We were going to do this loop invariant example. All right. So now I'm going to go through the first part. What we're going to go through here is I'm going to tell you what I would do in 3101, the algorithms course, and I'm going to tell you what the Java program is. So everything I'm doing now, I'm going to give to you on the test. And it's 2 pages of reading, but hopefully 1 that you can understand it, and 2, one thing that I always teach people is not to panic. Right? Suppose somebody throws you in the deep end of the water. If you panic, then you will likely drown, right? But my goal, what you need to do is, well, not panic. Do a little, just try to keep your head above water and try to, move forward. So when I give you this test, it's going to be 2 pages of reading to start with, and you might panic, but don't panic, because 1, you don't have to understand it completely to answer the problem, and 2, I'm hoping to go through it, that you should be able to go through it and understand, and 3, we will have a tutorial on Friday where we can go over the question. All right? So the first thing I believe in, I'm religious about various things, and one of the things I'm very religious about is I believe you need to understand loop invariance. All right? So what is a loop invariant? Is suppose you just arrive in the middle of a computation, right? I like to say you fly in from Mars, but somehow you're just here, right? You're here in the middle of the computation. You don't really know what happened in the past. And a loop invariant tells me what's true at that moment. All right? So let's go through it here. It's called loop invariant example, but we're going to start with what is our goal? Our goal is to go from the input looking like this to an input looking, we're going to start with the tape looking like this, and we're going to end with the tape looking like this, right? So, and are you going to do the entire computation in one go? No. If you do, I promise you that you'll panic and you'll drown, all right? Because how do you do that all in one go? Get a Turing machine to go from here to here. You have to write all the states and all the transitions. You got to understand them. That's crazy hard. So instead, we're going to do one step at a time. All right, what's here? This is, I'm starting at my precondition. I'm going to my postcondition. And I can think about what do I want to be true in the middle of the computation, right? So a loop invariant is just an assertion that tells you it's at a particular point in the code, and it tells you what needs to be true when you're at that line of the code. And why is it useful? Because it helps you understand the algorithm, and it helps anybody reading the program later to understand what the program's doing, right? Right? And it should flow nicely, right? Each step we move from what's true here to what's true here to what's true here to what's true here. We just do one step at a time. We don't worry about the whole thing all at once. All right. So what is my input? The precondition is going to be my input has the form blank in the first cell, and then it's going to have some 0, 1, and string, and then it's going to have blanks for infinity after that, right? That's what the input's going to be. What's the required output? This blank and this blank line up. So they're the same blank on the tape, right? And why are we doing that is because the tape is written here. I mean, the input is written here, and we're going to slowly destroy that. And as we slowly destroy it, we're going to write the answer here, right? And what's the answer? Well, you take the same, here we got 5 characters. You take the same 5 characters here, and before each of them, you put 2 zeros. You might say, why are we doing that? I don't know. It doesn't matter why we're doing it. We're doing it. Now, on the other hand, why we're doing it is, well, maybe we need more, the Turing machine needs more space for each character to be able to store things. And I'm just shifting things so that that space will be available to solve some other problem. And we're not covering that other problem here, right? We're just covering how to do the shifting, all right? So everybody get precondition, postcondition. All right, so now I'm saying let's leap into the middle of the computation. And what do we want the Turing machine state to look like, right? Well, what do I want? Well, I can't handle them all. I have a bunch of characters here. Can I handle them all magically at once? No, I'm going to handle them one at a time, right? And if I handle them one at a time, if I jump into the middle of the computation, what's true at this point in time is that I've already handled some of them, right? And I'm ready to handle the next one. So suppose I've handled I of them so far. And what's my value of I? Well, it could be 0 if I've handled none of them. But in this case, I'm just doing an example here. I'm doing an example where I've handled 2 of them. So let I be 2. And here I have I red because it's telling me that I've handled these 2 red guys, right? And so what do I want?
Can I ask you a question?
Yeah.
Is there any reason why you pick 2 numbers instead of 1 numbers?
Why I let I equal be 2?
Yeah, no, because I watched your video on the website, but
Right.
you told the student that you separate into red color and then the green color, so you will do 2 looping variant.
No. I want I could be 0, I've handled 0 of them. I could be 5, I've handled 5 of them. It could be anything. And 2 is just an example.
Okay.
And why did I make it 2? Well, because I like to think I jump into the middle. And 2 is approximately the middle of 5.
Okay.
And you could say, well, start with the beginning. But I find it's more helpful to start with the middle example, right? When I'm designing an algorithm, I jump in the middle and I say, what do I want things to be true in the middle? And then I make a little progress while maintaining the loop invariant. And so then I go back and I check, does it work at the beginning? Does it work at the end? But I find when I design the code, it's best to design it as a generic case, right? And so by having it be 2, it feels a little bit more generic.
To me, that's less generic than like having 1 for 5 times. Like pick up 1 number and then do 5 times of a loop and adding 3 0 at each looping time.
Well, do you want to run this whole code for this input could be really long. I don't want to run it for the whole run. I'm going to run it for 1 iteration.
Okay.
Right?
Okay. Right.
I'm lazy. I'm only going to do this for 1 iteration. Which iteration one do you want me to do it for? I could do it for the first one that doesn't feel like it's a generic one, or I could do it for the second one. Right?
So I guess you don't really know what input is going to be. That's why you can't have to do it this way.
I don't know what the input is, and I need to design this code generically so it works for every iteration. So let's just jump into a generic iteration. In fact, it's a generic value of I. I could be 0, but in my picture, I only can draw 1 picture. So in the picture, it's 2.
Professor?
Yes?
I was just wondering, so that I, is that at all similar to like the I you would put in like a for loop in Java, or is it?
Yes, exactly.
Okay.
This is a for in the Java code, we'll be iterating over the value I.
So this has a same function to that. Okay.
Yes. Yeah. What is our code Java code is going to say, oh, I have to shift all of these things. So let's I go from maybe 1 to n, and now I is 2. And when I is 2, what's true is I've shifted them 2 already, and I'm now going to shift the third one, the I plus first one.
Okay.
All right. Now, the truth is, in a Turing machine, can we have the variable I?
No, there's no variable.
No, because it can't. Why not?
There's no variables in a Turing machine.
Well, 1, there are no variables in a Turing machine. But 2, the state can't remember I. And the reason it can't remember I is because the input could be arbitrarily big, right? And if the input's arbitrarily big, then the Turing machine, the I could be arbitrarily big, and I have to design the Turing machine before I get the input to have a fixed number of states. So the Turing machine can't know I. All right, but I just have I here. How are we going to store I? Well, the way we really are going to store I in the Turing machine is we know where the head is. Right? Well, we don't know where the head is. So anyway, let's go on. We have here, in fact, so what's true is there's some I that the Turing machine doesn't know, and the first 2 characters have been handled. What does that mean? Is that we've done the 1 here, and we've done what have we done here? Here. We've handled these two, so we blanked out the 1 and the 0, right? And we haven't blanked out the other characters because we haven't done them yet. And after the blank, what have we done? We've done 0, 0, 1, 0, 0, 0. That's this 1, and this 0 has been handled, right? Everybody see that when we've got this, we've handled the first two things, and they're over here. And how are we going to know that they're handled? Because we don't have an I. We remember that we've handled them because we blanked them out. Right? Everybody good? And it's also telling me where the head is. The head is going to be sitting on that first blank right up there, which is kind of nice. Let me just say one more thing. It's kind of nice because if I happen to equal 0, then my head would be right here, where, you know, it'd be right at the beginning where it's supposed to be, and we can flow right from there. All right, you had a question?
Sorry, I just wanted you to repeat that. You said that how we changed it to blank. I'm not really getting it. Sorry.
I'm not really changing anything to blank. Do you understand the contents of the tape?
Not really.
Do you understand that this is the input?
Yes.
It's written on the tape. Do you understand what the required output is?
Yes.
Right? It's just the same input with 3 zeros put before every character. Right? You understand that?
Yeah.
All right. So in the middle, so this is what the tape looks like at the beginning. This is what the tape looks like at the end. Now we're saying, what will the tape look like in the middle of the computation, right? So what will it look like? Well, in the middle of, after I've looped, every time I loop, I'm going to handle one character, right? And if I've looped twice, then that means I've handled two characters. And what does that mean? Well, the characters that I've handled, I'm going to put a B on top. And what B stands for blank. And why do I put them on top of it? Is so that it helps us remember that we've handled them. So we don't have to handle them again, right? And then the 1 and the 0 that we've handled, their answer has been put out here, right? 0, 0 character, 0, 0 character. That's what the, yeah.
So after we put the zeros for the first two ones, the head moves back.
That's not your problem right now. Don't worry about the code yet. We're just trying to figure out, understand what the loop invariant is. What's true at this point in the code, right?
Sir.
We're gonna, yeah.
So we had B10010B. So that's the input. So did we add the zeros? Did we make it extra? Like we add the zeros to the
here?
Yeah. So like I'm just thinking how these zeros came in. From where did they come?
So in the code, we started here. And we've been running for a while, right? And so let's not ask how we did it. Let's just ask what happened before this point in time, right? I'm arriving at this point in time. And I don't care how we got here, right? That's not my problem, right? That's somebody else's problem. I don't care how we got here. All I care is what's true right now, right? And what's true right now is I've handled some number of characters. And what does it mean to have handled them? It means that I blanked out those characters, and for each of those characters, I put 0, 0 character. Right? That's what I've done in the past.
You basically looked at the output. You saw that there's 3 zeros, right, after the blank, like the first blank. Then you knew what to do in the loop invariant, because this is this is how we're supposed to do it, right?
Yeah, I'm designing this loop invariant. Right?
Okay.
We haven't written code yet. So when I say I don't know what the code did, it's because I haven't even written the code yet. Right?
And the rest of the zeros that we have in the output is basically by keep running the loop.
Yeah.
Right?
All I'm saying is if at the beginning it looks like this and at the end it looks like this, what do I want it to look like in the middle? Well, this looks like a good place to be in the middle.
Sorry, so just want to confirm. The I, it represents iteration, right? So like
in this case, it's iteration, yeah.
Okay.
Right? What is the loop invariant true. This is loop invariant sub I is going to be what's true after I've done I iterations. All right? So for example, loop invariant 0. What's loop invariant 0? It says I've done 0 iterations. So I've done 0 characters. And when I've done 0 iterations, I'm really right here at the input. And what's true? I've done 0 characters. So look at, I've blanked out 0 characters, and I've done 0 things over here. Right? So that's a loop invariant for I equals 0. This is what's the loop invariant for I equals 2. What's the loop invariant for I equals 5? Loop invariant for I equals 5 is that I blanked everybody out, and I have everybody done, all 5 of them done here. Right? So what's nice about this loop invariant, remember I said I want my little guy is flowing, right? I state this loop invariant here. Here I drew a picture for I equals 2. But look at, this is actually a picture for I equals 0. And this is actually a picture for I equals 5. Right?
So, sorry, I just have one question now. So for the loop invariant, the ones I don't know how to say, but run over, we just put them at the front, so we keep pushing them like forward.
You're talking code here. Please, nobody talk about actions in code. There's no action here. I have not said anything about action. All right? We haven't written code yet. I'm just drawing pictures. A loop invariant is a picture. And I'm saying, when I equals 0, this is the picture. When I equals 2, this is the picture. When I equals 5, this is the picture. All I want you to understand is the picture.
So we don't even need to understand why it's like that. We just need to we just need to know how it should look like, not why it looks like that.
Yeah. Later we're going to write code. I'm not saying we're not going to write code later. I'm saying right now, what I want you to understand as a general rule of thumb, what I want you to understand is what's on the slide. And if it's not on the slide, then don't panic that you don't understand things that are on the slide, because I haven't taught them yet. All right? What I've taught you is this is the input, i.e. what's true after 0 iterations. This is what the picture is going to look after 2 iterations. This is what the picture is going to look after 5 iterations, which is the output. So does everybody understand that?
Yeah, so this is just essentially showing how the loop invariant is maintained, right?
No,
each iteration.
no. Maintain is a verb.
Okay.
Right? I haven't talked about maintaining it at all yet.
Mm-hmm.
I've talked about the picture of what is at this moment.
Sir,
Okay.
So the output that we have is, what I understood is that we need to add 3 zeros between each number.
Add is a verb. Please do not talk about add. Do not talk about verbs right now.
Sorry, sir.
Not on the slide. Don't try to understand it. This is a picture.
Sorry, I just have, a way to kind of understand it is like, I don't know, maybe when you're cooking, you have a list of ingredients, then what you're actually using, like the ingredients to make. So the loop invariant is just like the ingredients. You don't need to know what you're making, you just need to know the ingredients.
Yeah. So this is a picture. So suppose you were following a recipe, and at the beginning, they had a picture of all your ingredients. So this is the picture of my ingredients. And then at the bottom of the menu, of the recipe, they have a picture of what you cooked.
Like the directions to like how you cook.
No, we have no directions yet. We're only doing pictures. Directions are about actions.
No, the directions are the code. That's what I
Yes,
mean.
but we're not doing directions yet.
Oh, okay.
Directions will be code, but do you see any code here?
No.
No, it's only pictures. So your recipe has 3 photographs. It has a photograph of what's true at the beginning. It has a photograph of what's true in the middle. And it has a photograph of what's true when you're done. We haven't done any directions yet. We're just looking at the photographs. All right, everybody good with that?
Professor.
All right.
Sorry, just a quick question regarding the loop invariant, just so I can understand the picture better.
Yeah.
Is the loop invariant the condition that must be true when we enter the loop, or is it the state that must be true when we are in the loop?
It's what needs to be true every time you're at the top of the loop.
Okay, so it's the state that, sorry, it's the condition that needs to be true before we enter the loop, right?
It's both. The first time you enter the loop, you're at the top of the loop.
Yes.
Right? So when you've looped 0 times, it needs to be true. And note, this is true when you've looped 0 times.
Yes.
Right?
Okay. Okay, thank you.
All right, everybody get our picture. So now we're going to do one step. Forget about the entire computation. Just worry about one step. Oh no, right now what we're doing is I'm just drawing the picture again. Here's the picture for I, and here's the picture for I plus 1. Everybody we got 2 pictures here? Right? This is the picture for I equals 2. This is the picture for I plus 1 equaling 3. Right? So now we have a goal in our life now, is to write code to go from this to this. Right? You don't have to do anything else. All you worry about is maintaining the loop invariant. We believe that the picture looks like this. And when we're complete our job, it's going to look like this, right? And we have to design code that's going to go from one to the other, right? Does that make sense? Now we're going to talk about actions. This is a picture, and this is a picture. Now we're going to design code to go from this picture to this picture, right? And you should all be able to figure out how to do it, right? I'm in this picture, so I know. What do I know from the picture? I know the head's looking at a blank. So I look at the tape. Is it a blank? Yeah, it's a blank, so I'm good. If it's not a blank, I'm going to panic. But it is a blank. So what am I going to do? I'm going to move my head right. Now my head is on this character. What am I going to do? Oh, that's the character I'm supposed to be handling, right? I move my head over here. How do I handle that character? Well, I read it and I remember it. I remember it's a 0, and I write a blank on top of it. And then I keep moving right till I get to a blank, and then I move past the blank, and then I move right until I get to a blank, and then I move past the blank, and then I write 0, 0, 0, and then I write the character that I just read. And then I'm happy. So then I go back until I get to a blank. I go past the blank. I go back till I get to a blank. And then I'm on this blank, and I'm done my task, and I stop. Right? People, that's a rough thing, and we're going to do it again. Everybody kind of get that? Right? So, first off, that was how to go from here to here. First, I'm going to talk about how to establish the loop invariant.
Can you explain it once again, please?
What?
Can you explain it once again, please?
Do what once again? Everything I said here?
The
All
previous
this?
slide.
Yeah, no, we're going to do that again. That was just, it's not on the slide, so I was talking out of hand. It was just to give you a flavor for what we're going to do. We're going to do it on later slides. All right? So first, somebody was wanting the first iteration. And I don't like doing the first iteration first, but actually we're not going to do the first iteration. We're going to get to the top of the loop. All right? So what do we know? The input says that it looks like this, right? That's the picture for the input, right? What's the picture for loop invariant 0? What's 0? 0 is I equals 0. That means that I've iterated 0 times. That means I've handled 0 characters. So what is my input? What does my tape look like? Well, I've blanked out 0 of them, and I've put 0 of the answers past the blank, right? So this is what it's going to look like when I'm at the top of the loop. Everybody agree with that? that this is loop invariant 0, right?
Why is there a second blank at the end?
Why there's a second blank is over here, there's a second blank, and there's, when I equals 2, there were 2 blanks here, and there were 2 times 4 characters between the blanks. Now I equals 0, so there's going to be 2 times 0, which equals 0 characters between the blank. And so that's why I have 0 characters between the blanks. But remember, here, this is an infinite number of blanks. I just gave you one of them. Here, there's an infinite number of blanks. So really, these 2 pictures are the same. Right?
On a test, if we just wrote one blank, it would still be.
Everybody's in such a panic about the test. This is the loop invariant, and this is the input. This is the precondition, which it says is true, right? This is the loop invariant. What's true going after? You're not even doing any of this on the test, right? When I'm teaching you here stuff you should learn for 3101. So it's not even on the test. So don't panic too much, right? It just says, how do we get the picture from this here state to this state? Nothing. There's nothing to do, right? There's nothing to do because we're done already. All right, so now let's do one step of the machine, right? Remember, this is how we do at the end, right? Suppose at the end, we've blanked everybody out. When we blanked everybody out, then everybody's handled and we're done, right? So we don't need to do anything at the end, right? Does that make sense? This is the loop invariant when we've handled all in characters. You blanked them all out and we've done them all. And all the point is we're saying, then we're done the problem, right? So all we have to do is maintain the loop invariant, all right? All we have to do is learn how to handle one character. So here we are. That's our picture. And what do we want to do? We want to learn how to go from here to go to here. Right? Does that make sense? All right. And what are we allowed to do? We're allowed to move the character. We're allowed to read characters from the tape. We're allowed to write characters to tape. We're allowed to move the head left and right. We're allowed to change our state. That's what we're allowed to do. Right? So let's write. Now again, you might be panicking because, okay, all this Java code, right? But you're not going to be writing this Java code. I'm going to be writing the Java code. In the past, I made you write this Java code, but you didn't have enough time on your test in an hour and a half, and people got panicked. So I don't make you write the Java code anymore. All right? So I'm giving you this Java code, but let's just flip through it, the Java code, and see what it does, because I am giving it to you, and you should have some understanding of what it does. All right? So what is the Java program going to say? I'm going to give you code like this, and what it's going to say. It's going to tell you the precondition is what's true about the input, is that we have some number of characters in the 0, 1 input, and that the head is sitting on the B, right? So the head is sitting here at the beginning, right? And what's the postcondition is that the output on the tape, required output is on the tape where the input had been. Actually not, it's shifted over. So I kind of lied to you there. All right, what's the loop invariant? That's the loop invariant I gave you before, right? Imagine, let's not try, this is all very abstract, right? Here's an abstract description. But let's be concrete and pretend that this is what the world looks like, right? It's a concrete situation. We have this concrete situation, and we want to move forward, all right? So now we're going to write some code here, right? So we know from the picture, we're just following the picture. We know that the Turing machine head is on this blank, right? And so if it's not a blank, we can panic, but it is a blank. So what we're going to do is we want to move our head over. So the first thing we do is we move our head right, right? Everybody good with that? Bang, there, look at what did I do? I just move my head right. And what am I, oh, I don't know why this is moving. What is the next thing I'm going to do? Is I'm going to take the value that's written at the head and store it in a new variable. I didn't have a variable A before, but now I have a new variable A, and I store it on my in my states. I store it on my Pooh Bear's blackboard, right? So I've taken this value 0 and I've stored it on the blackboard, right? Then what am I going to do is I'm going to write a blank on where the head is, and I'm going to move the head right. So let's do that, right? Oh, here's a little question. Do I write I equals 2 or 1 or 2 onto my blackboard?
No.
No. Why not? Because I can get too big and my blackboard is small, right? My blackboard's of a fixed size that can't depend on the input, right? The A is 0, 1. That I can write on the blackboard. But the I grows with the input, and I can't write it on the blackboard. So that's why we said, no I on the blackboard. So here, I knew we moved the head. Here I moved the head, right? So what we did, right? So what happens? We moved the head, we wrote the blank, we stored the A equals 0, and we moved the head, right? Everybody follow all that?
So I was originally 1, then it became 2 when you moved the head?
No, dude. I is 2. It's how many characters I've done so far. I will be 2 for this entire program. I will always, for our entire thing here, I is going to be 2. Only when we get back to the top will I be 3. All right, so now we're in the middle of the code. All right, so here, what did we do so far?
Like if I will be 2, and does that mean A will be equal to 2 plus the first input then?
No.
Oh.
Okay. I don't know what you mean plus. We're not doing any addition here.
Oh, what about the line 2, like bit?
This here?
Bit at head, yeah.
Yeah. So here. So let's go through here. I'm on line 1, and so at line 1 I know the loop invariant's true. So I know I have this picture, right? And if this is my picture, what do I want to do? I want to move the head over, right? So there, I moved the head over. Really, I should be on line 2 now. I didn't. So that's a mistake. Soon we're on line 2. What does line 2 do? It says take the value of the head and store it in A. I just gave you a little hint here. What character that's the I plus 1 character. In fact, that's the character I is how many characters we've handled so far, and now we need to handle the I plus first character, and so that's the 0. We're handling it, we're storing it in A.
Okay.
Right? And then we write a blank on top of the head, on top of the 0, on top of the value that we need to be handling, right? Our goal is to handle that 0, handle that I plus first character. How do we handle it? We read it and we blank it out, right? So we read it, we blank it out. And then we need to start moving right. So what do? We start moving right. So now where are we? We're here. We read in that character where that blank was used to be a 0. We read it in, we stored it in our Turing machine. And then what did we do? We blanked this out and we moved our head right. Right? See how I'm changing the picture as we go along, right?
Yeah.
Right? And I'm now on line 3.
Okay.
Everybody good? So where am I now? Now I'm in line 3, and this is what my picture looks like, and this is what I have stored on my blackboard. Right? Everybody good?
Yeah. So now you just keep moving until you find another blank?
Yeah. So now what's line 3? Line 3 says, move the head right until it is at a blank. And then I give you a little extra, i.e. after the remaining input, right? So this is the remaining input, and I'm going to move right until I get to this blank, right? So move right until you get to a blank. All right, so let's do that. Boop. Oh, what happened there? That was sort of funny. I don't know why that jumped up there for a second. But here we're,
Professor,
yeah?
in the test, we don't have to write statements, right? We have to write transition functions.
Yeah, why do people, yes. How many times have I said, this is, I wish people would focus on learning and not focus on the test. One of the problems with me telling you what's on the test is then you're obsessed with not learning anything unless it's on the test. I think understanding this is good to understand.
Sorry,
Next time, I'm
Professor.
not going to tell you what's on the test so that you can learn everything.
I'm sorry for asking that. It's just there have been a lot of questions and I felt confused.
All right. So what we're doing now is we're following this code. We have our picture, and we keep knowing the picture. We see what actions we're going to do next. All right. Let's forget about the test tomorrow, and let's see if we can understand this Java code. And then when we understand the Java code, we will convert the Java code into a Turing machine. All right, so let's focus on what we're doing right now. So do you understand that right now we have this picture and we're on line 4? Everybody get that?
Yes, sir.
Yeah.
All right, so now, what do we know from the picture? We know we're on a blank, right? Because what did we do? We moved right until we were on a blank. So from the picture, we know we're on a blank. So what do we need our code to do? Well, I don't like being on a blank. I want to keep going, right? So what does line 4 do? Line 4 moves the head right once more. And here's just the note. Where is it? It's moving us into the output, right? Because that's output, right? So we do line 4, and bang, there my head is past the blank, and I'm now on line 5, right? Everybody get that?
Yep.
Then what does line 5 do? Line 5 moves the head right until it's at a blank, right? i.e. after the produce output. This is the produce output. I'm going to keep moving right until I get to a blank, right? So let's do that. Bang. Now I got to a blank, and I'm now on line 6, right? Everybody good with that?
Yeah.
All right. What is line 6 to 9 doing? This is a bunch of actions. I'm going to write a 0. I'm going to move right. I'm going to write a 0. I'm going to move right. I'm going to write a 0. I'm going to move right. And then I'm going to take the value of A, and I'm going to write the value of A. All right? You ready to do that? Bang. See? My head was here. I wrote the 0. I wrote the 0. I wrote the 0. Oh, now I'm ready here. What do I do? I write the 0. Now I write the character, right? That was 0, 0, 0 that I just wrote here, 0, 0, 0. And now I'm ready to write the A. I take the value that's A. I write the A. I made it red, right? Because it's an actual character. Everybody follow that? And now I've done 6 through 9, so I'm now on line 10. Right? Everybody good?
Yeah.
All right, so now the picture looks like this, and I'm on line 10. Right, see, having a picture helps me move along. It helps me know what to do next, right? So I have this picture, and what do I want to do next? Is line 10 says, move left until you get to a blank. So you move left to a blank. And then line 11 says, move 1 to the left past the blank. So there I move 1 to the left past the blank. And then line 12 says, if you're on a blank, that means we're done, right? Because when we moved past this blank, we moved into the input. And if there's no more input, then we're done. So when we move now, if this is our current picture, if you happen to be on a blank right now, why are you in a blank? Because there's no more input to process. So if that's the case, then exit the loop, all right? But it's not the case. So let's go to line 13. What does line 13 do? Line 13 moves the head left until it's at a blank. So we move left till we're at a blank. And now what's true? Look at this picture. That's the picture we wanted to produce. So we're done our job, Right? Everybody get that?
Sir, can you repeat what happened in line 6 to 9?
6 to 9, we wrote, the head was here. We wrote that 0, we moved right. We wrote that 0, we moved right. 3 times. 0, 0, 0. We wrote them, we moved right. And then we took the value of A that was here and we wrote it.
So on line 5, it was at the last blank, right?
Oh, I don't know where it was at line 5. It was either at this blank or
Come to the end on line 5.
Here, yeah, line 5, we moved right to we're at a blank. So here we moved right past these and got to this blank.
Yeah, so on line 5 it was at the end. So how did it come back to 0 on line 6 to 9? Like
Here,
if you go to
let's
line
see.
5.
Okay, let me work through it here.
Yes.
In line 1, we're at this first blank.
Yes.
Then we read the character, and then we move right until we get to this line. Line 3 moves to this blank, and then line 4 moves past this blank.
Yeah.
Line
Up to
5 moves to this blank. Line 6 writes
Yes.
to 0.
So on line 6 you can come back backwards and like write the zeros.
Yeah, you just follow one step at a time and see how the pictures moved along. So everybody gets a general sense of this, right? The actual detail, you're not writing this code, so you don't have to worry. You got the general idea of how this works?
More or less.
Yes. More or less. So let's,
Professor,
yeah.
so is these set of instructions like line 1 to 13, is it specific to this example or is this in general, you can follow this?
Well, this code here is
Yeah.
clearly solving this problem.
Okay, I understand.
Yeah. Yeah, a different problem will have different code. This code, what does it do? It solves this problem. Right? All right, so now we're going to write Java code. And now what are we going to write? We're going to write Turing machine code, right? So, remember what our steps were? What I told you on that paper. I said do each of the lines of code, we're gonna have to do something, right? So let's start with line 1. Why? Because that's a good place to start. And it helps you know where you're going along. So we start at line 1, and then what do I tell you to do? I tell you to read up about the loop invariant, right? Because the loop invariant was right there, so you know what's true, right? And what's true is that we have that picture up there. Everybody agree? So what I know is I'm in line 1 and I have that picture, right? So what are the various options? What variables do I know? Well, I don't know any variables. Look at my Pooh Bear thing is empty. The loop invariant doesn't say I have any variables. The loop invariant might tell me I have variables, in which case there's things written on my blackboard. But the loop invariant tells me I have no variables, so my blackboard's empty. So what do I know right now? Well, I don't know where the head is. The head's just somewhere. I don't have anything in my blackboard. All I know is that I'm on line 1, right? So what state am I in? I'm in state. Hey, dude, I know that I'm in line 1 state, right? This is the name of the state. Everybody good with that? So then I say, well, what character might I be reading? Well, I could be reading a 0 or 1, but the loop invariant tells me that then the program will crash. What should I be reading? I should be reading a blank. All right, so let's pretend that things are the way they're supposed to be, right? I'm in line 1, and as I expect, I'm reading a 0, right? So now we're filling in one cell of the delta function. It says if you're in this exact state and you're reading this exact blank, what should you do? All right? So let's read the code. What I tell you to do is read the code until the head moves. All right? So let's read the code. What happens? We move the head right. Oh, dude, the head moved, right? So that was pretty quick. So after that, what state am I in? Well, I'm in line 2. The state I'm in is that I'm in line 2, right? Do I have any variables yet? Well, line 2 will give me a variable, but I don't have it yet. Line 2 is going to make the variable. So when I'm starting line 2, I don't have a variable yet. So I'm in line 2 with no variables. So all I know is that I'm in line 2. And what character should I write before I move over? Well, I don't want to mess up that blank. It was a blank. So I'm going to write the same blank. And what direction do I move the head? It told me to move right. So I move the head right. Right? Does that make sense? Everybody good? There, we have done line 1. Everybody understand?
Sir, so the B we have is the same B, like the same blank we have in the tape, right?
Yes.
Yes.
Yes. Here I'm reading the blank, and I don't want to change it, so I write the same blank on top.
And we just get the direction now, which means go right. Okay.
Yeah, we go right. So what do? We change from line 1 to line 2, and we move the head right.
So the state is now line 2.
Now I'm in the state called line 2.
Okay.
Everybody good with that?
I just have one quick question. So could
Yes.
you please go real quick with the delta function? Like it says the state line 1 and then B. So is it like the current state that we're looking at B, or the next we're gonna move to?
Yeah, so the delta function is going to have what state am I in? I'm in the state called line 1.
Okay.
What character am I looking at? I'm looking at a blank. Okay, given that that's the case, what should I do? I should move over to line 2.
Okay.
I should write a blank and then I should move my head right.
Okay. Makes
Right?
sense.
That's what line 2 does, right? What do you do when you execute line 1? Well, you go to you move the head right and you go to line 2. That's all line 1 does.
Okay,
right?
thank you.
And why did we have a line 1? It's because we needed to move our head right. Right? Does that make sense?
Yeah.
Right? It's not very hard. So it might be scary because it feels, oh, that's too easy. Well, but that's line 1 isn't very hard, right? Everybody good with line 1?
Yes.
All right, let's go over to line 2. All right? Oh, here, I do tell you to kind of fill in the whole table. So if you're filling the whole table, you have to say, if I'm in line 1 and I read a 0, what should I do?
I panic.
You panic, exactly. Because you're not supposed to read a 0. The picture tells me I'm supposed to read a blank. And I'm not supposed, so if I get a 0, then go to panic, right? Everybody good with that?
Sorry,
All right,
Professor.
Yeah.
Just to follow up with that, would that mean line 1 has 3 states? B, 0, and 1?
No. There's one, the state is Q line 1. That's the state I'm in.
Mm-hmm.
And then what characters can I be reading on? So this is one row of the table. I'm in state Q line 1.
Gotcha.
Now, what character am I reading? I might read a blank. I might read a 0. I might read a 1. Right? If I read a blank, then I go to this state. If I read a 0, I go to panic. If I read a 1, I go to panic.
Okay. So would it be more accurate to say that line 1 has 3 transition functions?
It's, I would say, more accurate, but not. There's one transition function. I would say line 1 has one state, which is Q line 1, which is one row of the transition function. And the transition function has 3 columns. And the 3 columns are, I read a blank, I read a 1, I read a 0.
Okay, so you're saying the 0 and 1 would be empty if we imagine the table.
No, if we imagine the
No?
table, we have one row
Yep.
called state line 1.
Mm-hmm.
Then we have 3 columns.
Yes.
The one column is headed, when I read a 0, what do I do?
Mm-hmm.
The entry is I panic. The next column
Okay.
is I read a 1. The entry is I panic. The next
Mm-hmm.
column is I read a blank. What do I do? What's the entry? Is go to line 2.
So the Q panic, that state panic, would that
Yep.
be like an actual, sorry, not the state panic, whatever the panic is that would be an actual thing we write there, or would it just be nothing written there in that column?
No, here, this is what I'm writing. I'm writing go to the panic state. And when you do go to the panic, and what do you do in the panic state? Well, maybe you halt, maybe you write some error message, maybe you,
Yeah.
probably what you do is you put up a message which says something went wrong and you program, call your system administrator.
Okay. So it would be accurate to say halt, right? Halt would be accurate here?
Sure, that would be halt. That would be accurate. I'm happy with going into the panic state. I don't care.
Okay.
I mean, that tells me that things didn't happen right.
Okay. Gotcha. Thank you.
So I have a question again.
Yeah.
So do we cover all the cases, like when we're in state line 1, if
Yeah.
I see B, then I go to line 2. If I see
Yeah.
0, I panic, and then
Yeah.
in
Yeah.
case if I see
Yeah. Yeah.
So
Here we just finished the entire row of the table.
okay, so we cover all the possibilities.
Yeah. You're gonna have to fill in the entire table. We just filled in the first row.
Okay, just to make sure. So with the next state, like if we go to line state line 2, do we do the same? Like if we see B, we
Why don't you
do
wait
this?
for it? We're gonna do it right now.
Okay, got
We're
it.
gonna do all of these until people leave.
Right.
Right?
Okay.
So here now I'm in state. Why are people still arriving to this course? Okay, now this is the picture, right? And I'm in line 2. And do I have anything? In fact, what I like to do is I just copy from here down here, right? Here, I knew I went to line 2, right? So I know I have a state called Q line 2, right? So I know here I kind of handled the first row, but I also created a second row, right? I started talking about a new state. So now I have a state that I have to deal with. So now let's go down and deal with that state. Here, what are we going to do when we're in line 2? Right? Well, we know the picture is this. We know I'm in line 2. We know I have no variables, right? So my state is just line 2. So what are the questions? Well, I'm reading some character. What character I'm reading? Well, in the picture, it's 0, right? But in reality, it could be 0, 1, or blank, right? So if it's, let's say, what is it? Well, let's cover the cases 0 or 1, and we'll worry about blank later, right? So if it's a 0 or a 1, now I'm filling in. This is going to be the second row of the table because we're doing line equals 0. And what column is it? Well, we're doing 2 columns. We're doing I'm reading a 0 column, and we're doing I'm reading a 1 column, right? So I'm filling in a block of the table this time. I'm filling in 2 entries, right? And we want to know what we're going to do. So in order to know what we're going to do, we're going to read the code, right? We're going to run the Java program. So what does the Java program do? Well, we don't have a variable a, but it assigns a value to a. So what I'm assuming here is that we allocated space for the variable a. So we allocate space for a, and what do we store in a? We store the value that's in the head. What's the value in the head? Oh, that's C. So we store a we store this value C in variable a, and then what do? We write a blank, Okay, and we move the head right. Oh, we're moving the head, so this is done, right? We have to finish our thing. So what state am I going to be in? Right?
Line
Right?
3.
Line. I just did line 2 and I moved the head. So what line am I in?
Line 3.
Line 3. Do I know any data? Do I have anything written on my blackboard?
No, but
Yes.
Yes.
E, right?
I have A. A is going to be written on my blackboard.
A
right?
equals C.
A equals C. So what state I'm in? I'm in line 3. I'm in the state where A equals C. Now what is C? Well, C is either 0 or 1. If I'm the table says if in the column where I'm reading 0, I go into state A equals 0. In the column where I'm reading 1, I go into state A equals 1, right? So I'm just filling in 2 entries of the table, right? When C equals 0, fill it in this way. When C equals 1, fill it in that way, right? Does that make sense?
Right.
So that's the state I'm going into. What character do I write? I'm going to write, there was a C, but I'm writing over the C, I'm writing a blank. And what do I do with the head? I move it right. Everybody good with that?
Sir, I just have a question about C. So does it mean that C contains like the whole loop, like I mean the whole tape, like it has 0, 1?
It's just 0 or 1. Right now, I'm telling you, C is 0 or 1.
Oh, you assign it. Okay, okay.
Right? I'm reading, what is C? C is the character that I'm reading. What could it be? It could be a 0, or it could be a 1, or it could be a blank, and we might have to worry about what we do if it's a blank. But
Yeah,
right
and
now,
a blank
we're just saying it's a 0 or 1.
Okay.
Right? So okay, now I haven't filled in the character, what to do if I'm in line 2 and I read a blank. And maybe I forgot to do that. Actually, it seems if I'm a blank, then I'm already here, so there's nothing else to do. So maybe I should have exited there. But anyway, let's ignore that. Let's say now I'm in line 3. Oh, in fact, what I like to do is, remember, I like to take this state, I'm in this state, and I copy it down here. Right? So when you're filling out your answer, it's nice just to take this and copy it down here. I know if I'm in this state, I go to this state. Oh, now, what happens if I'm in this state? Line equals 3, A equals 0. Watch it, we're going to copy it down. Here, line equals 3, A equals 0. All right? Now, right, line equals 3, A equals something. Now I have 2 different C's. Why do I have 2 different C's? One C is the value that I read before. It's the value that's stored on the tape, right? That I read in and I blanked over. All right, so that's the one C is the value that I read in and I wrote. And the other C, the C prime, is the new value that I'm reading, right? So I was in the state, line 2, I moved to the state line 3, A equals 0. So now I think, oh, I'm in state line 3, A equals 0. So line 3, A equals C. C is either 0 or 1. And now I'm going to read a new value, right? Here's the new value that I'm reading. What is the new value? Well, I'm hoping it's a 0 or a 1, right? It's the case where it's a 0 or 1. I have to worry about blank, but right now it's a 0 or 1. So let's read the code. What do I do? Move right until it's a blank, right? Okay, so I read that, I see there are 2 cases, right? Remember I told you sometimes there's 2 cases. What are the 2 cases? It is a blank, I'm going to do something. If it's not a blank, I'm going to do something, right? So let's handle the first case where it's not a blank. And if it's not a blank, then what the C prime that I'm reading is, here the C prime that I'm reading is either a 0 or 1, i.e. it's not a blank, right? And now, what do I do if it's not a blank? Well, I move my head right. right? All I do is move my head right, right? Everybody see that? So if all I do is move my head right, what state should I be in? What line should I be in?
Line 4.
No. No, I'm moving. I'm going to stay in 3. I'm staying in 3, moving right. So if I don't get a blank, what state line am I in?
3.
Right? I'm still in 3. I'm still in 3, right? Because here I'm in 3, moving right, still in line 3. It's a little loop, right?
So the new line
equals
will
C
be
prime?
blank. Right?
So I'm going to be in line 3. What's the value of my A going to be? Am I going to still have an A?
C
Right?
prime? No.
No, because it didn't tell me to change the value of A. Right? It just tells me to move right. C prime is the value I'm moving past. If I'm looking at a C prime and it's 0, 1, then move past it. Right? What does it mean by move past it? Write it back into the cell and move right. But what do I stay in my variable A? My variable A doesn't change. Right? Everybody see that? So, people following this? Let me go it over again. Suppose I'm in line 3. And what's true in line 3? What's true in line 3 is I had some variables saved, right? How do I know that? Well, because I started with the loop invariant and I've been following the code, right? So I know that when I'm in line 3, I'm line 3 and A has some value and it has some value C. What is C? I know from the previous line that C is either 0 or 1. All right, so now I'm reading some character. All right, so now I say, what does the code do? Well, there's 2 cases. Either it's blank or it's not a blank. All right, so let's handle it's not a blank case. So what am I reading? Well, I'm reading a not a blank. What's not a blank? It's a 0 or 1. All right, so great. What does the code do when it's not a blank? When code is not a blank, the head keeps moving right because it keeps moving right until it's a blank. So if it's not a blank, what do? I go right. All right, so what is my action? So I'm going to move right, but I'm going to keep moving right. So that means I have to keep being in line 3, right? I'm going to busy wait in line 3, right? That's what the until means. The until means that we have a little loop here, right? So move head right until. All right, so we're going to keep staying in line 3, and I didn't change the value of A. I'm not going to change that I'm in line 3. I'm going to keep being in line 3. What am I going to do with the contents of the tape? Doesn't say to do anything with the contents of the tape. It just says to move right. So if I'm reading a character that's non-zero, not blank, I'm going to write that character back on the tape so it doesn't change, and I'm going to move my head right. Right? What is this? Yep.
So just to clarify, so we
Yep.
we stay in the same state until the action is done?
Yep.
Like, okay.
Yeah. So I just note that somebody put a note that the time's up. Yeah, for sure, the times was up. I'm willing to go through this, but you guys can do whatever you want.
So if once you have, like, once A equals C, right? So it's not a blank, you just keep moving right. I'm just confused about how you got the 3 B's before this.
Sorry, how we got what? I didn't, yeah.
I don't know. I'm just confused. It's fine. Just, I don't know. Keep going.
All right, well, so you got that we have this picture here, right? So let's just follow the picture. I'm in line 3, and I'm storing A in A has 0. So I'm in line 3 and A equals 0. That's the state I'm in. C happens to be 0. And then I run the code. And what does the code say? It says move right until there's a blank. Well, seems like that's a case, right? Blank versus non-blank. So let's do non-blank. So I'm reading, move the head. It implies, there's a character where the head is. So right now the head's at a non-blank. So let's C prime be the character I'm reading, right? A has 0, so that's C. But C prime is this 1. C prime is that character right there that I'm reading, right? So let's execute, assuming that I'm looking at a 1, right? So what does the code say to do? It says if it's not a blank, then move right until, right? So maybe the English isn't bad, but it seems to me stay here, moving right. So, right, that's how I would read this. So what does that tell me to do? It means stay at line 3. This says stay at line 3 until you get a blank. Well, I didn't get a blank, so what I'm going to do is I'm going to stay at line 3, right? And so that's the state I'm going to go to. From this state, I'm going to go to that state. And look I didn't even change states. I'm in the exact same state I was before, right? But what's changed? What's changed is I read a character, I wrote the exact same character back. So the character hasn't changed. That hasn't changed. What has changed? I moved my head right, right? So now my head is on that 0, right? So let's do it again. Now I'm at line 1, line 3. What's on my thing is still A equals 0. So I'm in the exact same state. But now I'm reading a C prime that's no longer, it was a 1, now it's a 0. I'm reading C prime, the character I'm reading is a 1. What should I do? Oh no, it's not sorry. It's not a 1, it's a 0. I'm reading a 0. What do I do? Well, it says move right, unless it's a blank, move right. Maybe I should have said that. If it's not a blank, move right. If it is a blank, then you're happy, right? So I could have changed that. Change this to, if it's not a blank, move right. If it is a blank, then go to the next line, right? So it's not a blank, so I'll stay in the exact same state. I'll write the 0 back and I'll go right. So that puts me here, right? Everybody see it? Now, this is the picture. Now what state I'm in? Well, I was in this state and I moved right, so I'm still in this same state. I'm still in the same state, but now I'm reading a blank. So what do I do when I'm reading a blank? Now what do I do?
We have to update C prime, right?
Yeah, what character? Update C prime. I don't know. No. We don't update C prime. All we're allowed to do is go to a state, write a character, and move the head. That's all we're allowed to do. We don't update anything.
Okay, so we're just going to change the line of where it's blank.
Change what?
The line. Like, we were at line 3, and we're going to now become at like the line where it's blank.
Yeah, so now this is the picture. And I'm trying to fill in one entry of the table. The entry of the table is I'm in the row where I'm in this state. Now I'm in the column where I'm reading a blank. What do I want to do when I read this blank? Well, I need to say what state I want to be in, what character I want to be in, and what I want to do with the head. All right, so let's start reading it and see what happens. I'm in line 3. What's going to happen? I see a blank. So the until is kind of done, right? So I go down to line 4. Well, should I stop at line 4? Well, I kind of gave you the hint, keep going until the head is moved. And I haven't moved the head yet, right? So what does line 4 do? Line 4 moves the head. Oh, now I've moved the head. So what line am I now? I've done line 4, I've moved my head. So what line am I in? I've moved all the way to line 5. My value of A hasn't changed. What character do I want to write before? I want to write the blank there, and line 4 is moving the head right. So I move my head right. Everybody get this step here?
But then it was line 4. Why would you put a line 5 there?
Why did I go to line 5?
Instead of, like, why would you just skip to line 4?
Well, because I want to have as few states as possible. So I would prefer, if I don't need a state 4, why have one? So the hint, when I gave you the steps, I said, run the code until the head moves, right? So if I'm here, I'm in line 3, and I'm reading a blank. That's the case. The case is I'm in line 3, and I'm reading a blank. So what does the code do? Well, if it's in a blank, it's until blank, so I'm done line 3. So I go to line 4. And then what does line 4 do? Line 4 moves the head and goes to the next line. This is where I'm here. I just moved the head, right? Okay. I run it until I've moved the head. Right? Run until you move the head. Now stay, where are you now? Well, I'm in line 5 now. And what character should I write before I move the head? Well, I was reading a blank, and I don't want to mess it up, so I'm going to write a blank before I move the head. And then which direction did the head move? It moved right. Right? Everybody get that?
I had a question regarding A equals C. So we said that we couldn't hold a variable inside of our states, correct? So shouldn't it be C prime? What do you mean?
C is not a variable. So maybe I should have, A is a variable.
Yes.
C is a value 0 or 1. And maybe it would have been less confusing had I done C prime and C double prime.
Exactly, yes. So that's what you mean though, right? It's still an element of 0 or 1. Okay.
Yeah, C is an element of 0 or 1. And the reason I didn't need C as a variable, C was never a variable. C was the character that I read. Right?
Okay, gotcha.
So
thank you.
So here I'm using I have 2 values, C and C prime. Yeah. Yeah, maybe C prime and C double prime would have been better. I don't know. All right, everybody, now, again, now I have this, right? Now we finished the line 3 table. 2 rows. We did 2 rows. We did line 3, A equals 0. Line 3, A equals 1, right? We just completed 2 rows of the table. And now we have a new state. And so we have to figure out what to do with that state. So I said, now, suppose I'm in this state. What am I going to do? Right? Everybody good up to here? Right? So I'm in this state and I'm reading some character. Now I got this picture, right? I'm thinking, okay, what do? I move right until there's a blank. So this is kind of what we did before. I'm reading. There are 2 cases. I'm reading a character. I'm not reading a character. I'm reading a character. Or I'm reading a blank. Right. So let's assume I'm reading a character. C prime is the character I'm reading. And what do? If I execute the code. I move right until it's a blank. Right. So I busy wait. I stay in 5. I'm still in state 5. I write that same character and I move the head right. So all I've done is move the character.
Jeff,
yep.
I just have a question about, so if you keep on, let's say, like we never encounter blanks, right? And we just keep on seeing constants, just consider that, right? We don't need to account for any exit condition or anything, right? Like you just.
Well, we know the picture is going to look like this. We're not going to have 0 1s forever, because that would mean we had an infinite input. And if we had an infinite input, then the program would run infinitely, right? So we know we're going to eventually hit a blank.
Okay, gotcha. Thank you.
But yeah, you're right. This program, I'm not guaranteeing this program works. I'm just doing what the program does. And certainly, if it ran right until there was a blank and there was no blank, it would run forever, right? We have to trust our picture that the input started off as finite and that we're going to hit a blank. All right, so now we're doing the other case. Suppose I'm in line 5. So this is the state I'm in. And I get a blank. What do? Well, if I'm a blank, so it drops out of line 5. Oh, here's a little tricky. It drops out of line 5 and does line 6. In line 6, what does line 6 do? Line 6 Oh, where are we, by the way? We're all this. We should be this guy here should be way up here at the this blank. Anyway, we're at this blank here, right? Move head is right into the blank. Oh yeah, because when we arrive at yeah.
Does line 5 and line 3 get repeated? Like they're the same thing, right?
Yeah, because one is moving to this blank, and now we're moving to this blank.
Okay. Okay.
Right? So now we're on this blank. The head didn't move, but pretend the head is now on this blank. Right? We're on this blank. What do we want to do? We want to write 0 on top of that blank. Right? That blank is going to be replaced with a 0, and we're going to move our head right. Right? So what line, that's what we're going to do. We're going to write a 0 here, and we're going to move our head right. So then what line will we be in? Will we be in 5 anymore? No. We'll be in 6? No, we were going to write the 0. We're in 6. So what line should we be in? We should be in, oh, we're in, here, I made it, so I could have gone right over to line 6, right? But here is an example where I tried to, line 7, but here's an example where I tried to make this easier by having it stay. So here I'm going to say, I could have gone on to line 7, but instead to make it easier, I said if I'm in line 5 and I'm reading a blank, then I'm going to go to line 6 and I'm going to keep the head. I'm going to keep the head on the blank, right?
Sir?
Yeah.
So without the picture, the only way we would know where the head is at is by reading the loop invariant.
Well, there's no loop invariant down here. The way you get the picture is you get the picture from the loop invariant at the top, and then you trace through the picture as you come down.
Because, oh, okay, so I got it.
Right. So I don't give you a loop invariant for every line. I give you the loop invariant at the top, and then you have to change the picture as you come down.
Sir, for the last line you wrote, so are we expecting here that line 5 has a blank?
Yeah, if here, what does line 5 do? Line 5 either has a blank or it doesn't.
Yes.
And if it doesn't, then you keep at line 5 and you move the head right.
Yes.
If it does have a blank, that means I've arrived here. And when I've arrived here,
means stop.
Then I'm saying stop. Go to line 6 and stop.
Oh, right. I see. Oh, okay. So
right? Does that make sense?
You write line 6. Oh.
Yeah. Line 5 says stay in 5 as long as you don't have a blank. And when you have a blank, go to line 6. Right? So that's what this says. Everybody good with that?
Professor, I don't want to interrupt what you're doing, but
yeah.
if so like I understand how you can manipulate blanks to kind of iterate through, you know, the 0 1 0 1 0 1 or whatever characters. But if it was a nested loop, say, would you go to one of the values, right, and then kind of put it in the output and then iterate through the output after the last blank? Would that be how?
Yeah. So the Turing machine doesn't know anything about nested loops, right? And this, and you know, I'm sure you're asking this because you know that we're doing quicksort tomorrow, and quicksort has 2 loops, right? So there are 2 loops. So what you would do is, if I'm in a particular line, then you run there could be 2 cases, right? Just like here, I'm in 5, right? So there are 2 cases. In the one case, right? Maybe line 5 says exit when, right? I'm somewhere in the loop, maybe at the top of the loop, and there's a line that says exit this loop when. So what do you do then? Well, there are 2 cases. The one case is I exit, and the other case is I don't exit. So I'll have 2 cases. And in the one case, I say, what's my range of my guys? And if my range of the guys is that I exit, then I go from line 5 to the line that I go to, the line after the loop, right? And in the other case, I don't exit. So if I don't exit, then where do I go? I go from line 5 to line 6, right? Or maybe I'm at the bottom of the loop. Maybe I'm at line 13, which is at the bottom of the loop. Well, then there's no exit maybe at the bottom of the loop, so I automatically go back to the top of the loop, right? That's what I'm saying is, know what line you're in, follow the code until the head moves, and then tell me what line it'll be in next. So there could be, the code could have many loops, and it could have if and else statements, and it could have function calls and returns from function calls. And what do? If I'm in this line, I say there may be more than one case, and in this case, I follow the code until the head moves, and then I say what line will it be in next. Right? Does that answer your question?
That actually is really helpful. So like in effect, it basically it doesn't actually change because you're not I see what you're saying. I see what you're saying.
Right? Whatever the code is. So no matter how complicated the code is, I'm in line 5. That's the state. What state I'm in? I'm in line 5 with these various variables. I'm going to run the code until the head moves. Now what line am I in? Right? So you just trace the code until you're on some other line.
Okay. Thank you so much.
It could be, right, it could be you're looping. It could be an if else. It could be a return from a routine. It's just what line am I next? Right? All right, so let's go back to this. Everybody get this example?
Not really.
Not really. Right, not really. I thought that was Abdullah's voice, but Abdullah has her thing muted. I don't know whose voice that is. But look, what does line 5 do? I'm in line 5. I have something stored on my blackboard. What am I reading? I'm either reading a character or a blank, 0, 1, or a blank. So what does the code do? Oh, look, there's 2 cases, right? The case is am I blank or not? Well, if it's not a blank, then what do? I stay in line 5 and I move the head right. So that's what I do. If it's not a blank, I stay in line 5 and I move the head right. If it is a blank, well, then I'm going to drop out of this little mini loop, right? This is sitting in a little mini loop. I'm going to drop out of this mini loop and I'm going to go to line 6. It just says go to line 6 and stay there. All right, that's it. You guys got any questions about that? Should we move along? Now I'm in line 6. If I'm line 6, what do? Well, I better be reading a blank because that's what I got when I was in line 6. If I'm in line 6, I'm reading a blank, then what do? I write a 0 and I go right. So if I'm on line 6 and I'm in a blank, I write a 0 and I go to line 7. If I'm in line 7, I write a 0 and I go to line 8. And if I'm in 8, I write a 0 and I go to line 9. And each time I move the head right. Right? Does that make sense? 6, 7, 8. Right? In each of these cases, if I read a character, then I would panic.
Professor, for these 3, 6, line 6 and 7 and 8,
yep.
Can you show me where are they on the tape? Like just point it out with the mouse. Where are they?
All right. Here is line 6. I'm writing the 0. Then I'm on line 7. I'm writing a 0. And then I'm on line 8. And I'm writing a 0. And then I move over.
Okay,
right?
okay.
So
now
here it is. Right? I wrote those zeros. And now the head's here.
Oh, so, okay, because it was the first one was blank before. So you replaced it by 0. And you kept going.
Yeah, I replaced. What I did in 6, 7, and 8 is I replaced those 3 blanks with zeros.
And now is like line 9 has a blank?
Now I'm at line. It's a blank, right? It's a blank. And what does line 9 do? Line 9 is going to write the value of A.
Oh, so like here we're talking maybe about, okay, I see it now. There's two different sentences in the from 6 to 9. First part we made them zeros, and second part we're gonna now say write 0, head write A.
Yeah. The semicolon is changing line, right? Write 0, write a 0, head right, write a 0, head right, write a 0, head right. So that was 6, 7, 8. Now we're in 9.
Oh my God, I see it, sir. Yeah.
Right? Does that make sense?
Yeah, obviously. Yeah.
All right. So now I'm going to write a 0. I'm going to write the value of A, right? So I'm in 9, line 9. I'm still remembering C. What's C? C is either 0 or 1. C is the value of my A, right? But that's just my state tells me that. And I'm better been reading a blank because that's what my picture tells me. So what do I want to do? What line should I be in next?
Are you
line 10.
9?
Yeah, I'm in 9. So what line? I'm going to go over to line 10. And what, right? So here, let's adhere to it. I went over to line 10, right? And what value do I write on? What value do I write on the tape? Whatever value I have here stored, right? If I'm in the state where I'm storing 0, then I write 0. If I'm in the state where I'm storing 1, then I write 1.
Sir, so when we said write A at the end of the line 6 to 9, when we say write A, so does it mean that we gotta change the value that we have from the board, like
I'm going to take the value here.
Yes.
Take the value here, and I'm going to store it, and I'm going to write it on the tape. Right, the A is going to be written there.
Oh, but we don't change it when we wrote line 9, like the first statement you made, sigma q less than line equals 9, because this is where we are on line 9, right? And on line 9 we have to change A.
It doesn't say to change A. It says to write A. I'm writing the value of A whenever you only can write onto the tape, right? So when I say write, I mean write onto the tape. Here, I'm going to write the value of A onto the tape. How do I do that?
Okay.
Well, I'm in a state which knows the value of A, and so depending on the state I'm in, it's going to change. It's going to right. It's going to. I'm going to then write the value of C.
Okay, and C is 0, basically, because A is
now
0.
In this case, right, if C was 0, then I would be in state, there would be a 0 stored here, and I would be in state line 9, A equals 0, and I would write a 0. If C was 1, there would be a 1 stored here, and I'd be in state line 9, A equals 1, and I'd be writing a 1.
Thank you.
Right, does that make sense?
Where does the second B come from? The second blank?
Why is there a blank here? I don't know if there are an infinite number of blanks, so I don't know why did I give you 2 of them. I know why I gave you 2 of them, because I'm writing over this one, and this is the one that's going to be the end blank. Okay. I just draw a couple blanks that are useful. There are an infinite number of blanks there, and I happen to give you 2 of them. One of them we're writing over, and one of them we're not writing over.
So why did you choose A to be 0 when you said write A?
Because way over here, we read that value there to be 0. And in the line 2, we took the value at the head and we store it in A, right? And that happened to be a 0. And we're carrying this 0 all the way along here, and we're writing it there.
Okay.
Right? Does that make sense?
I'm sorry, why is A not equal to C prime instead of C?
A was, I was using C and C prime were both either a character, were both either 0 and 1, and C was the one that I carried right from the beginning, right? I read in a C here, and it stayed it stayed A equals C all the way through, right?
Oh.
We're back, if we go back to this thing here, A is C, which is 0 or 1, and I'm reading a C prime, and I'm going past C prime. So C prime is just symbolizing what I'm going past, right?
Oh, because I thought C prime meant like a specific C in the set of 0, 1.
C and C prime are two different. C and C2 prime are both represent 0 and 1. The C represents the value, the current value stored in A. I have two states. Line 5 A equals 0, line 5 A equals 1. Those are two different states. So I'm telling you for both of those states what I'm going to do. So it's a 2 by 2 square I'm filling in here. Right? Okay. This here tells me I have 2 rows and I have 2 columns. So one row, the rows tells me which state I'm doing, and then the C prime tells me which column I'm doing.
Okay,
right?
think
Does that make sense?
I understand. Yeah.
I have 2 different states and 2 different columns. And for those, so that now those 4 entries, I tell you what I'm going to do.
Sir?
Yeah.
I just had a question about the transition from line 9 to 10. So you mentioned to go into another state, the head must move either left or right. But for line 1, all you have is right A, but you didn't move the head either way. So how did the state change to line 10?
Well, here, this line is 10. So when I write an A, I go to line 10. And I could have kept, what I told you to do is keep running until you move the head. But there's enough confusing things happening here that I would say, if in doubt, go from line 1, 2, 3, 4, 5, 6, 7. And you might not get full marks if you do that, but you can get it to be right. So I could have, instead of gone to line 10, I could have done line 10 and moved on to line 11. But I thought that was too confusing for people, right? We're having a whole discussion already. So when things get to be too hard, just keep the head stationary. If you're really understanding things, keep moving until your head moves. But if things are too complicated for you, then keep the head stationary. So that's what we're doing here. We're figuring this is complicated enough. So I'm going to, what's the code going to do? I'm in line 9. Line 9 says write the A. And so it doesn't tell me how to move the head. So I don't move the head. And I go to line 10. So that's what we're doing here. We're writing the A, and we're going to line 10. So what are we doing? We're going to line 10. We're keeping the same variable here, and we're writing the value. That's what value does A have? A has the value C, so we write the value C. And why do we keep the head stationary? Well, because we just wanted to go from here to here.
Okay, makes sense.
Everybody get line 9?
Sir, why do we have a blank in line 9 again?
Because it's reading a blank.
Okay.
I should also tell you, if it's not a blank, then things are bad. And what do you do if I'm in line 9 and I'm reading not a blank?
I panic.
You should panic. But I think I've stopped giving you panics. I just gave you that one panic at the beginning.
Okay. So if you get that panic, would you like keep going or
when
you
panic, you panic and you drown. Things went bad.
Okay, so I think I'm just finding this a little confusing because line A is right, line 9 is right A, but you don't actually write A until line 10?
No. Where are we writing A?
Well, because line 9, like with the thing, like when you write it out at the very bottom, right? This is line 9, what it's doing if it sees a blank, right?
Yeah. So when I say write in A, where am I changing the value of A, or what am I doing here when I say write A? What's getting in? Let's forget about the Turing machine. Forget about the Turing machine. Let's think about the Java program. What does this write A mean? Am I writing into A, or am I writing the value of A somewhere?
You're writing the value of A somewhere.
And where am I writing it?
Wherever the blank is.
Wherever the head is.
Okay.
Wherever the head is, right? So this value is getting written where the head is, and the head is here. Now the picture tells me that the head is on a blank, and I'm trusting the picture. If the picture's wrong, I panic. So let's trust the picture that I'm looking at a blank. So what's the Java say? Line 9 says, from the picture, you should be looking at a blank, and what do? You take the value A, and whatever value A is, 0, 1, you write it there. So now we can write the Turing machine code. The Turing machine says, well, I'm either in one of two states. I'm either in the state line 9 where A is 0, or I'm in the state line 9 where A is 1, right? In either case, what character should I be reading? Oh, I better be reading a blank, or otherwise we have a bug. So I'm reading a blank, and what should I do? Well, I know I should write the A, so I should write the A on the head. So what do I put here? This tells me what should I write on the head. And the value what value should I write on the head? The value has to be 0, 1. So you only can put a 0, 1 here. You can't put a variable name. I put 0, 1 is a value. And where do I get that value from? Oh, if I'm in state A equals 0, then I write a 0. If I'm in state A equals 1, then I write a 1. Right? And what new state should I be in? Now I'm going to be in state 10. What should I do with the head? Oh, it doesn't tell me anything to do with the head, so I'm going to leave the head right there. So I'm going to write the 0 on the blank, and I'm going to leave the head right there. Right? Does that make sense?
Okay, so the reason that you don't put move right on the left-hand side of this is because this is sort of defining the cases.
Well, it's because...
Well, on the left-hand side, I mean, when you're in line 9, you're saying that it's either going to be...
Oh, I could move the head right again? Why didn't I move the head right? Is it because I didn't want to go on this blank? I wanted to stay on a character. I had no need to go over there.
Okay.
The code didn't want me to go over there. In fact, what the code's going to get me to do is to start to move left. Right? So why move right if what I want to do is start moving left? Now, if I was really fancy, I could have gone from 9-1 to 9-11 by moving, I could move, if anything, I would move left here. Right? If I was fancy, I would move left. But I felt that would have been too scary. So I just stayed put.
But in test, we can do that, right? That was my question.
Test, if you want, you could put a left here, because that's what you do next.
Because that will optimize the number of states, right? So.
Yeah. But it's a little scary because I only move left. Yeah, you could move left. You could move left here. It doesn't change the number of states, right? Because I'm going to need this. It doesn't save anything, right? That's another reason I stay, is because I'm going to need a line 10 anyway. It's not like I'm going to skip line 10 and move to line 11. Line 10 is very complicated. We're going to be in line 10 for a while.
Could we combine the right A with line 10? That's what I was trying to do earlier.
No, you can't get all of line 10 because line 10 is going to be busy waiting. And we only need to write once. So that gets way too confusing.
Okay.
All right. We got line 9 down. Should we go over to line 10? So before, oh, actually, we got more about line 9, I think. Oh, what? Something came on here and I can't read it. Something came on. See it coming over here? I don't know what that is. But let me tell you one thing I know about this. Do we need the value of A anymore? Right? We wrote the A.
No.
We don't need A. So I could say deallocate A, right? So look what I'm going to do is I'm going to write the value of A, and then I'm going to forget the value of A. Right? Does that make sense? And here, watch A. What's A going to do? Oh, I pointed it up there. This A up here, what's that A going to do? It's going to disappear. Right? So now I'm in line 10, and I don't have a value of A anymore.
Sorry, so both ways would be correct, right?
Yeah, I just have fewer states.
Okay.
I tell you on the test, I do tell you on the test, I explicitly say allocate memory, deallocate memory, allocate memory, deallocate memory. So you have to then you have to follow these instructions of allocate and deallocate.
Okay.
Here I didn't tell you to deallocate, so that's I only did it because I know at the top I didn't have any mention of A, right? So by the time I get back to the top, A should be gone. It might as well be gone now.
So when you say allocate memory and then deallocate, you mean like write A and don't write A, right?
No, I mean here, look at in line 9, I have memory for, I'm storing a value of A, right? My state up here, written up here on the blackboard is a value of A. And then in line 10, I don't have a value of A. So when I went from here to here, I deallocated A. And similarly, when I was in line 1, I didn't have a value of A. In fact, when I started line 2, I didn't have a value of A. And then here I needed a value of A. So by line 3, I had a value of A. So here I was allocating an A, and here I'm deallocating the A.
So does allocating and deallocating have anything to do with staying at the same position, or is that separate?
No, that's a separate issue. Allocating is if you have nothing written on the blackboard and then there's something written on the blackboard, that's allocating. And the other direction, if something's written on the blackboard and you erase it, that's deallocating. And the state I'm in tells me what line I'm in and tells me what's written on the blackboard, right? So here I'm in line 9 and I have something written on blackboard, and here I'm in line 10 and I have nothing written on the blackboard. So basically between here and here I erased the blackboard. In fact, up there, see it? It's going to disappear. Bang, it's gone. There, I just erased it.
Okay,
right?
That makes sense.
So that has nothing to do with what we're doing with the head. The head is a separate issue.
Sir, and in the test, do I have to show you that I erase it?
No, you go from this, you just write this. You go, I'm in this, I go into that. All you have to write on the test is this line. That's it. The proof is about this big, right? It's just you write this stuff.
Okay.
You don't have to discuss it. You don't have to say, oh, look it, I'm deallocating now. You just write the transitions. Everybody good? Okay, line 10. Now it's easier. Now what do we do? Again, we have an until. If it's not a blank, what do? I keep everything the same and I move left. Right? If it is a blank, then I go to line 11, and line 11 moves ahead once more, and then I go to line 12, right? So I can go to line 12, and right? I see a blank, I write a blank, I move the head left. Everybody understand those ones?
Sorry, can you just repeat that?
All right, so I'm in line 10, right? I'm in line 10, nothing's written. Oh, nothing's written on the blackboard. The blackboard should be blank. I'm in line 10, I know nothing. Now, what happens in line 10? There are two cases. The one case is there's a blank, one case there's not a blank. So here I'm having my two cases. In one case, it's not a blank, it's a 0 or a 1. And what do I do if I have a 0 or 1? Well, it just stays in line 10 and it moves the head left. So I stay in 10. I read a character, I write the same character because I'm not supposed to be changing the date, and I move the head left, right? Now let's look at the other case. So suppose I'm in line 10 and I've been moving. Here we go. Let's see, there we go. Oh, we move. Now I'm on this blank, right? I'm sitting on this blank. I've moved left. Now I'm sitting on this blank right there, right? And so what do I do? If I'm on a blank, well, if I'm on line 10 and I read a blank, what am I supposed to do? I'm supposed to break out of this line 10 and move to line 11. Now, what do I do in line 11? I'm going to move the head, right? I can keep executing until I move the head. So when I get a blank, I didn't move the head. So here in line 11, I moved the head. So now what I'm doing here is I'm moving the head for line 11. What do I write? Well, I'm not changing the head. Remember, I was reading a blank, so I'm going to write the same blank. So I'm reading this blank. I'm going to write this blank, and then I'm going to move the head left. And what line am I now? My head is on this 0, and I'm on line 12.
So you skipped 11 because
10 when it was a blank didn't move the head. 11 moved the head, and so I moved to 12.
Yeah, this part is confusing. This is really confusing.
Yeah, this is what we did. It's the same as what we did up here, right?
that was confusing too.
All right. Well, let's try it again. So, do you have any questions, or should I just say it again?
So why is it line on the first transition function? Why is it line equals to 10 again? Because we know that it moves left on 11, but it would still move down to 11 first, right? And then move left?
No. You're not on, yeah. What you're saying is wrong.
Oh,
so let's be on line 10. Here you are sitting on line 10. You're looking, you have the head somewhere, right? So what does line 10 do? Line 10 says, move left until you get to a blank. All right, so let's forget about this right now. Let's just make sure we understand what the Java code does. What the Java code is going to do, it's going to stay in line 10, moving left until we get to a blank. Is that how you interpret?
Yeah.
How are you interpret
I got
this?
it. Yeah,
right?
I got it now.
It says if you're here, move left until you get to a blank. So this whole duration, what line am I in?
10.
Line 10, right? All along here, I'm in line 10. So as long as there's a character, what do? I keep that character the same. I stay in line 10. I keep the characters the same, and I move left. So that's what we're doing. We're staying in 10 until I'm at this blank. Does that make sense?
Yeah, but so if we don't find a blank, then it moves to 11, right?
No.
Oh.
Just the opposite. What does it say? Move left until there's a blank.
Okay.
If it's not a blank, move left. These are not blanks. The B is a blank. These are non-blanks. Move along non-blanks. Stay in 10 non-blanks until you get a blank. So that's what this is saying. This is saying if C prime, the character I'm looking at, this is the character I'm looking at, C prime. The character I'm looking at is a 0 or a 1. Then stay in line 10 don't change the character on the tape, and move the head left.
Yeah.
Can I ask a question?
Yeah.
When we move from line 10 to line 11, can we say we stay in line 11 and then we do another state from line 11 to line 12? Can we do that?
Yeah, you could. I personally would take off the little marks if you did that, because I want to see that you have some creativity of moving further, but it could be right. So now let's think about what we're doing for a blank. All right, for here. If I'm in line 10 and I get a blank, then what do? Well, I'm supposed to move left until there's a blank. So if it is a blank, then I'm done line 10. So what I could do, I could go to line 11. I'm done line 10. I could go to line 11. I keep the blank there, and I could stay, because I didn't say to move the head, right? So here.
So we could
here, let me do it for you. I'm doing it for you. Let's take this and double it. And then here I'm going to put stay. And here I'm going to put 11, right? So I could, from line 10, write the blank and keep the head in the same place. And then I'm in line 11, and I'm still reading a blank, right? Because I just wrote that blank. And then I go to line 12, and I keep the blank, and I move my head left, right? Do people understand this code?
But you would take marks off if we did this.
Well, I'm marking it, the TA's marking it, but I wouldn't take off a lot of marks. I wouldn't panic. Suppose the test is out of 100. Maybe you would go from 100 to 99. I mean, I wouldn't cry over this.
I don't get why line 11 okay, I got it, I think
Right.
I got it.
Everybody understand this? Where I'm in 10, I go to 11 and I stay, and then from 11 I go to 12, and because what does 11 do? 11 moves the head left and goes to 12, right? Okay. So 10 goes to 11 and stays, and 11 goes to 12 and moves the head left. So does everybody understand this code?
So can I just clarify? So the reason why, I just want to make sure I'm understanding this right. So the reason why it says stay there is because we're at line 10 and there's no other, we can't move anymore because we already moved all the way until the blank. And line 11, we can't say it moves left there because that's not what it's trying to tell us to do. We just move forward to the next line, but we don't do anything until we actually get to line 11, and then it gives us a command to move left. And that's why we say left, right?
What does 10 do? What does 9, 10. What does 10 do when it gets a blank? Nothing, right? If you're on line 10 and you get a blank, what does it do? You're supposed to move until you're a blank. I'm on a blank, so what do? Nothing.
Yeah.
What do? I go to line 11. So if I'm in line 10 and I read a blank, I do nothing, and I go to line 11.
Oh, sir. So this is why on line 4 you just basically didn't even write it. You just skipped along because you just said move head right, and we just did.
Yeah.
Okay.
So here I'm in line. So these cases where I do it 2 steps, I did in a previous example, so I didn't do it in this case, right? So here from 11 I could stay, and from 10 I stay. From 11, what does 11 do? 11, all it does is go to line 12 and move left, right? So here everybody understand this code?
Yeah, so this is why you said, well, if we have in the test 33 lines of code, it doesn't mean that we're going to actually go through all of them.
Yeah, if you do this, you're going to have 33 times 2, like some of them will have 2 examples, right? So you'll
Yeah.
have 32 times 2 lines to write, right? And the marker
Yeah.
is going to have to read 33 times, it's going to have to read 66 lines, right? So
That'll
I'm
be
just
too
saying,
much. Yeah.
take this one and take this one and delete them.
Sorry, yeah, okay. I feel like I get it now. It's just, I don't know. It's harder to understand going from like the shortened version to the longer version than it is to go from the longer version and then understand why you can take stuff out.
Yeah, so I know. So maybe in this example, I should have gone to the longer version and then gone to the shorter version. But you have to remember, we did jump to my hardest Turing machine example. We went through a number of examples earlier in the slides, and they did long version and then did short version. So when I got to this example, I didn't do long version and short version. I assume that you'd already known that, so we just did short version.
Okay, sorry. I don't know. It's just like it's just hard to know because I guess I'm not completely comfortable with this, what
Right.
you can take out or not.
Right,
So
right.
it's like,
Well,
oh, well, I think this is kind of an insignificant, obvious step, but then I don't want
right, so let me tell you the only things you can take out. All right? Let me tell you what you can take out. Turing machines, when they only need to change state when it learns something new. And it only learns something new when it moves the head. So as long as the head's is not moving, you don't need to change states. So remember that description I gave right at the beginning of today's lecture. What I said was, okay, pretend you're in some line, keep running until the head moves, right? So that's what I did. I was in line 10 and I read a blank. What I said is, let's keep running the code until the head moves. So here the head didn't move. Here the head did move, so I'm in line 12. Right? So in general, what you're going to do is there's 33 lines of code, but I'm telling you, you're only going to need 6 of them or 7, a few of them. So if you're in a particular line, then what are the lines going to be? They're going to be, allocate memory, deallocate memory, move stuff here, move stuff, write this, write that, read this, right? I give you lots of instructions. And then there's an instruction that says, move the head. And when you move the head, that's when you need to do a state change. Does that make sense? Why can I delete this line? Why do I not need to go to line 11? It's because the head didn't move, right? The Turing machine did not learn anything by going from state line 10 to line 11 to line, right? It didn't learn anything. The head didn't move. Right, so if you want, what you could do is you could write out if you want full marks and you're in a panic state, and you don't know how to do it, then write out every line, write out every of the 30 lines, and say stay, and then start over. Get a new piece of paper, and delete everything that says stay. Right here, I went from here to here, and I stayed, and I went from right. So then I can delete those 2, and I can go straight from here to here. Does that make sense?
Sir, by saying the head did not move, right?
Yeah.
Well, on step 11 it says move head left 1.
Yes.
So that means you move the head, right?
Yes, but in line 10 I did not move it.
Oh,
right?
I see. Because
here I'm moving it, but if it's a blank. If it's going from line 10 to line 11, I stayed.
Okay, so like you always have both of the possibilities where maybe if it's a blank or it's not a blank. That's what you're. what we need to write down. So there's two different options here, like we
There
have.
are two different options, but that's a different issue. That's
Yeah,
a
yeah.
separate issue. The
Yeah,
issue
but we
here
can-
is this right there where I'm staying. I happen to know instead I could keep transitioning until I get a head move. So here, what's the Turing machine doing? It's going from here to here, and then it's going from here to here. Well, did I need to do that in 2 steps? No, the head didn't move. So I'm allowed to delete this, but then I don't have a line 11 anymore. I have fewer states. So if I have fewer states, I don't have a line 11 anymore. So if from line 10, where do I go? I got to go somewhere. I'm going to go all the way to line 12.
Yeah, this is pretty new. Like, I don't know. Yeah.
It's just confusing when the step says move head left 1, but then we can it just seems like it shouldn't be something you can remove, because how am I showing?
Then don't remove it. Then don't remove it. If you would prefer not to move it, if you don't understand the fact that we can remove it, then I'm going to call you a perfectly good B plus student, right? Maybe even an A student. But if you don't understand we can remove it, I'm not going to call you an A plus student, right? And that's fine. All right, if you're happy being an A student, then that's good enough. So just ignore this whole thing about moving until the head moves, and write the code like this. You won't have a dozen lines of code. You'll have maybe 66 lines of code. That's okay. You can do that if you want.
Sir, why do we write stay again? Just to confirm.
Why do we write stay?
Yes.
Okay. Suppose we're in line 10. In line 10, there are 2 cases. The one case is there's a blank. All right, so now let's do the case. I'm in line 10, and I'm reading a blank. Here I am. I'm in line 10, and I'm reading a blank. So what do I do next? I'm going to run the program and see what happens. Now, my advice was run the program until the head moves. But you don't want to take that advice. So forget that advice. So instead, we're going to say, just run the program until you're in the next line of code. So here I am. I'm in line 10. I'm in a blank. What do? I don't do anything, except I go to line 11. So that's what we're doing here. I'm saying, if you're in line 10 and you're reading a blank, don't do anything. Have the head not move. Don't change what's on the tape. All we're going to do is go from line 10 to line 11. That's what the Turing machine is following the Java code. It's going from line 10 to line 11. And it's not moving the head. What does line 10 do? If it's a blank, does it move the head? No. It moves the head until it's a blank, and then it goes to line 11. Right?
Yes. Now on line 11, it says move.
Now what does line 11 do? Line 11 moves the head and goes to line 12. Right?
Oh, so it's like the bridge between 10 and 12.
Now this is what line 10 does. This is what a line 11 does, right? So that's what you can do if you want. You can write what does line 10 do? It keeps the head stay. What does line 11 do? It moves the head left, right? You can write that. Everybody good?
Yeah, because I just asked because when you said stay on, so line 11 be stay, because you already said that when we are on line 11, we're moving to line 12. So I was what stay?
You got it. Line 11 doesn't stay. Don't read this. Line 11 stays. Line 11 doesn't stay. Line 11 moves its head. It's line 10. Line 10 moves to a line 11 and doesn't change the head. That's how you should read it, right?
Okay, now I get it.
Line 10 moves to line 11 and doesn't move the head. Line 11 moves to line 12 and does move the head.
Okay, yeah.
Right? Everybody, I'm just reading the code here.
Yeah,
Just
because
reading the code.
has nothing to do with what's in it. Like it's just gonna move whatever it got from 10. Okay.
Yeah, line 11 doesn't even read, right? I happen to know it's a blank, right? I could have put here,
Yeah, I see.
Yeah.
It's just
Anything, right?
Carrying the same head over. Yeah.
Right? Could be, if anything is there, well, it better be a blank. I was just here, dude. Right? Why would it suddenly not be a blank? But line 11, if you're just on a line 11, you don't know that, right? Line 11, what does line 11 do? It copies whatever was there, right? And it moved the head left. Everybody good?
Yep.
Should we stop? The rest is just the same. It's just.
Sorry. I had one specific question.
Yep.
And it was specifically about, so you were showing us like the hints and stuff, like on one of the slides. So it basically says like Q, and then some state or like some line, and then C is equal to like whatever, but like it says C prime, so it's different, and I was confused by why it's different, because I remember in one of your lectures you said that the C doesn't change because the Turing machine only knows exactly like what state it's at in that moment. And see how at the end here it says the function and then comma C and then equal to, and then here it says C prime. So C and C prime are two different things, right?
What are you talking about? Yeah.
Oh, sorry, at the bottom.
Here?
The very, very, very bottom.
Here. C and C prime?
Yeah.
Yeah. Yeah, so yeah.
So it would only be different if we're replacing something with something else, right? But
yeah, if you look here, it says, what are we going to be writing? Well, the one case is you just write what was there before, right? If you don't want it to change, right? Either because you don't want it to change, then if this is C, you write C. You read C, write C. Read C, write C. That's what you do when you don't want. If you don't want the contents of the tape, here's a rule of thumb. If you don't want the tape to change, whatever you have written here, write here.
Okay.
Right?
Okay.
If you do want it to change, then this is what you're reading, and this is what you're changing it to.
Okay. Because at first, like, I was confused because I thought this meant it's moving forward and it's somehow able to see the next line, but it can't do that.
No,
it can't read it. Yeah.
This is, I'm reading a C. What am I going to do? I'm going to write a C. I'm going to write the C, or I'm going to write a C prime, and then I'm going to move my head.
Okay, I understand now. Thank you so much.
Yeah. And everybody see here, I mean, let's go through this again, right? What do you need to do? You need to fill in the whole transition function, right? You need to tell me the start state, and then you need to do the transition function. So what you do, you start in line 1, and then when you're in line 1, what do? You say, line 1, the loop invariant tells me what the picture is. So draw out the picture. Make sure you understand the picture of the loop invariant, right? And then then you say, oh, well, do I know everything about the loop invariant? Maybe there's two cases. Maybe there are a bunch of cases. Maybe I'm looking at a blank, or maybe I have this value, or maybe I have this value p. I have some value p prime that's less than q prime, or it's bigger. I have various cases. So decide which case you're working on, right? Then, given I'm on line 1 and I have a particular case, right? Then I say, given that, what's my range of my p's and my q primes? Well, maybe my range is that they're between 0 and 9, but they have this property, right? And then say what state I'm in. I'm in this state. All right, now what am I reading? Well, I'm in a particular case. Maybe I'm reading a blank. Maybe I'm reading a value. Maybe I'm reading a value that's bigger than p prime, right? What is my range of the character I'm reading, right? So now we know I'm in this state and I'm reading this character. Then what do? You start running here in your mind. Run the Java program. Well, if you want, you could run the Java program to the next line, right? But then you're going to have 33 lines, right? If instead of running to the next line, you could say, where did it again? Run the Java, in your mind, run the Java program until the head moves, right? And then the head moves, what state? After the head moves, now we want to say, right after the head moves, what's going to be true? After the head moves, what state will I be in? What line will I be in? What values will I have written on my blackboard? What character, before the head moves, right? I'm just moving the head. What character am I going to write in the head, where the head was before I moved it, right? Because I ran the Java program until the head moved, and just before I moved the head, what value do I want to write where the head was, right? Maybe it's the same value that was there before. Maybe I have a new value. I ran it until I moved the head. Now, which direction did the head move? Did it move right or left, right? I'm saying it didn't stay. Why didn't it stay? Because I ran the Java program until the head moved, right? So it is moving. Now, if you run the Java program just until the next line, then maybe the head doesn't move, right? But then you're going to have more lines. If you run it until the head moves, then the head moves. And then you say, if I'm in this state and I'm reading this character, what's the new state? What do I write in the tape? What direction does the head move? And then that finishes that block. Now I'm in line 1, but I have a different case. So I do line 1, the other case. I do the whole thing. And then what do I do next? Well, do I have to do line 2? Not if we move past line 2, right? If when we did here, in your mind, run the Java program until the head moves, if we move from line 1 all the way to line 7, then we don't have to do this for line 2, 3, 4, 5, 6, 7. We can now say, we're in line 7, what do we do next? There are two cases. I'm in line 7, there are two cases. Okay, in the one case, I do this, in another case, I do that. Now what line am I in? Oh, now I'm in line, now I went around the loop, so I'm back at line 1 again. All right, everybody get that?
Yeah, and I don't know if this is related, but just want to make sure, like, so the invariant, like
the loop invariant?
Yeah, loop invariant is going to be provided, right?
I'm going to give you the loop invariant. I'm going to give there. In fact, I can tell you, I've said already, it's going to be insertion sort. So you should know what insertion sort is. It has 2 loops, and in fact, it has an outer loop and 2 inner loops. And the outer loop and each of the inner loops has a loop invariant. So I'm going to provide you with 3 loop invariants and 33 lines of code. And whenever I want you to allocate new memory, I'm going to say it. When I want you to deallocate memory, I'm going to say it. When I want you to write on the tape, I'm going to say it. When I want to move the head, I'm going to tell you. And so really, I think if you're following what I'm saying today, you're going to be able to do the tests in a half an hour.
I seriously doubt that, but
Yeah, I
that's the goal.
seriously doubt it too, because it never happens in my life. But we can pretend that that's the case.
I think maybe 6 hours minimum or something.
All right, right. Well, do you know what you guys convinced me of?
Yes.
I was debating whether to have this question and then another harder question.
Oh my God, please.
Maybe I should delete the harder question.
Please,
Yeah,
sir.
please, sir.
That would be lovely.
There's no way.
I like the harder question. I like harder questions.
I know you do, but we don't.
I
That's the
stayed up
problem.
until 3 in the morning one night and was cranky the next day because I wrote up a harder question.
Could you
Give it
give
to
it
the
to us as
3101
practice?
students.
Or yeah. Could you give it to us as practice, and then like if we did something really hard, it might be easier for us to do it like something like this or something?
I mean, the one option is I give them both to you, and
No.
then just wait. Let me talk. And then if nobody does the second one, then the marks all will be low, but then they get belled up, and then but the people who do it, it's like a bonus.
But why don't we stay with the safe side and just do
Yeah,
the one?
I think one question's fine. It's
Because
fine.
some people will do it and some people won't, right?
Yeah,
Yeah,
just
but
because I'm not sure.
And then you're gonna
Like-
skewed results.
I mean, I must admit, if I wanted to, why would I give you an A+, right? Why would I give you a+? If in my opinion, if you can't do this question in 20 minutes and then do my second question in another 20 minutes, then I don't think you deserve an A+, right? And if you're happy with a B, then all you have to do is do the one
Sir,
question.
I'm not happy with the B though.
I mean, no one here is happy with the B.
Well, then
I
you
don't
should
think-
be able to. You should be able to understand this, and you should be able to do my. Now you're convincing me to give you 2 questions.
Oh,
I could give you 2 questions and not have the question worth that much, right? And then if you can do it, you'll get an A+. And if you can't do it, you'll get an A.
I mean, whenever I go into classes, my understanding is always important, like most important. I always want to understand concepts. Like, I don't care about like, if something goes wrong or I mess up or whatever. As long as I learn something out of it, that's what matters to me. But like, at the same time, it's really stressful, I think. Just going through a question, because it seems like a lot, and usually like I've seen. I mean, I've done one of your tests before, and it seems like a lot, but usually it's not that much. And I think that's where anxiety comes in, or just stressing, and
Right. That's
just
what
because of that.
I
Yeah.
tell you, if you take 3101 from me, for example, every test, I think it's going to be easy. I think everybody's just going to write down the answer and get it. Say, now I want an A+, and the department's going to complain to me that everybody gets an A+. And every test, everyone, 3/4 of the class just don't know how to do it. And then I give them the solution, and they say, man, that was easy. I should have gotten that. So that's what happens every test. And so that's life, right? I don't know.
Well, thank you so much for helping us today. I'm gonna go and study because seems like I am gonna need it. So thank you.
Alrighty. But yeah, so if you can follow what we did today, then this question about converting for the insertion short, really, we're just doing this exactly thing what we're doing here. You just do what I'm telling you to do. And I really think it should be easy. And if you're doing something hard, you're doing it wrong. You just have to understand the concepts and write them down. My answer takes this much paper. I don't know if you can see me still, but
yeah,
that much paper.
Just to ask the TAs don't hate us, Should we explain every transition function, or is it good enough just to write the meta transition functions?
My answer has this much paper.
Okay.
What does it say? It says P prime and Q prime and C are in this range. I'm in this state. I'm reading this character. What do I do? It's just those things that we had, right? The range of the variables, delta goes to, just bang, bang, bang. You write it. That's what the TA wants to read.
Okay, gotcha. So no other like extra language to explain what we're doing.
Well, I don't know what else I would put there. The explanation is the Java code, right?
Yeah.
Now, if you're not sure what you're doing, maybe you could say, "Hey, TA." I can imagine if I really knew what I was doing, I would just write it down.
Yeah.
If I was a little worried about what I'm doing, I would say, "Hey, TA, I think this is what I should do, but I'm a little worried about it because I'm thinking I'm a little confused about this. So maybe I should do this, or maybe I should do that. Maybe this would be a better thing to do." So that's where you could put some chat.
Okay.
Right?
Okay.
Because the truth is, if your answer is identical to my answer, which I hope it is, then the TA in 30 seconds will give you 100%. Right? Now, when your answer is different than my answer, now the TA doesn't, they're just a guy who's taken this course before, and they're going to be struggling with what you're doing and why you're doing it. So if you could give the TA a little help about what you're doing and why you're doing it, then the TA is going to have a hard time to know your answer's different than Jeff's. What is it right? How right is it? How wrong is it? Right?
I see.
And if you could help the TA know how wrong it is, and how that would help. But I'm not really sure what I would say, because, I guess I could write another full, I could have my answer be longer where I explain each thing, but I was tired of writing up answers. So
I guess I was just thinking combining like certain lines of code, being like, well, this transition function serves as lines of code from 1 to 7 or something.
Sure. Put some chat in.
Yeah.
Chat's always good, right? In fact, I'll tell you, when I'm a marker, what I like to see is I like it when people give me an answer where if it's right, I can quickly narrow in and see if it's right. And then I see all this extra writing that you're doing. You're doing all this extra writing, but I can narrow in. Oh, bang, he's right. Then what I do is I give you full marks and I don't read what you wrote, right?
Nice.
Because I'm lazy. I don't want to read it. If I can give you full marks and not read what you wrote, that's what I'm going to do. But then if I read, oh, here's the answer, and it's not right, then I have to think, oh, what was he thinking? Oh, he gave me all this extra writing, so I'm going to read all this extra writing and try to figure out what they're thinking. And it's going to take me longer, and you're going to get a lower mark, but maybe the extra writing will help me understand what you're thinking.
Okay, understood. Thank
All right.
you.
Sir, where can I find this this page? This one.
The one right there?
Yes.
What you do is you go here. Oops, where are we there? There, come. Oops, why are we jumping back? Okay, there. You know how to get to this 2001 page, right?
Yeah.
And then you go to machines. We're going to Turing machines, and there are the slides. Now you may have downloaded these slides already, and that wasn't there. That's because I wrote it yesterday.
Okay, so maybe they're the same slides that are in the section 2 under there, the ones that shows like a PowerPoint, because they're the.
So if you download them,
yeah,
you come over and then you open them.
Yeah.
Now you'll see in this new version, it says, oh no, that's the wrong course. Sorry, other course is this one. Now you go to the first page, and if it says steps for writing a Turing machine from Java, then you know how you start running them, and you click that, and it goes to it, right? And if you look at your version, you look at your version and it doesn't say this, then that means you have yesterday's version, right? And so what you do is you go back here and you download today's version.
Okay.
Does that make sense?
And also, when we send you an email, usually, like, do you see it personally or you see it with the entire class?
It always comes to me.
Okay. Because I just see the questions in the email. That's what I'm just asking.
You see what?
Like, you know, like when someone asks a question on the email, like we see it. I don't know why.
Oh, no.
Forum.
That's two different things. When you get an email, see who's it coming from. If it's coming from the forum, if you go to the forum here, right? You go to the forum, then you can write something. And when you write something, it spans to the entire class.
Okay. Right? So if I have a question or something, maybe.
If its question is if you want the entire class to get it, so that the entire class can help you answer it, then put it in the forum. Okay. If you want it to only go to me, then email Jeff@CSE.
Okay. Yes, thank you.
Professor.
Yeah.
So if I use the Turing Machine's solutions and questions on your website, would it be enough to review for the test?
What we did today is enough for the test. Yes.
Okay. So if I use the solutions from I think 2001 and 2017, was it?
Yeah.
It would be more than enough.
Yeah. So let's go back. Let's go back to here. Here's some extra questions, right? Turing machine solutions. Yeah. Solutions. So if we scroll down here, so let's see. We're not scrolling very fast. Here we scroll down. Here's some Java code. And in fact, it's the one we just went over, right?
Yeah,
that looks like we just
from the
did.
Website, from the slides
and if you
too.
come down to the answer, right? Here's some answer. Right? In fact, here I'm giving a little slightly different things. Right here I'm saying, I'm stepping it through it in a slightly different way. I'm saying, okay, just change the name, and I don't know what I'm writing here, but in the end, what does the answer look like? It looks like just like this, right? But here here on the test. Well, I guess you only had an hour and a half. This was a test at some point, right? Many years ago, this was a test, and you only had an hour and a half, and I gave you other questions, right? Because maybe there was a DFA question, and so I made you do line 9, and I made you do here. You're doing lines 3 and 4, and here you're doing line 9. So you didn't have to do it all. All right.
I see.
On tomorrow's test, you're going to have to do it all. So.
Okay. And for the partner thing, my partner messaged me yesterday. He said that he dropped out of the class.
All right. So then what you do is you email me, and what I will do is I won't mail you back until I have a partner for you. And so hopefully somebody else will mail me.
Oh, sir.
When 2 people mail me, then I mail you both. Yeah.
Hello? Yeah.
Yep.
I don't have a partner. My partner also dropped out.
Oh, excellent.
Yeah.
Excellent. 2 of you, why don't you tell each other your names, and I won't have to be involved.
Do we just write in the chat?
Yeah, sure. Write in the
I'll
chat.
send it on the chat.
Yeah, tell each other your names, and you're officially partners. That was easy.
Sir, can you hear me?
Yeah.
Sir, in one of your classes, you mentioned comparing the running time between the Turing machine algorithm and then the equivalent Java program.
Yeah.
Can you give a refresher on how it would make a difference? The Turing machine would have to move the head, so that would affect the running time, right?
Yeah. So you should know already, hopefully. Do you know the running time? Do you know the algorithm quick insertion sort?
Yes.
Do you know its running time?
I believe it's n squared.
Exactly. But now the Turing machine's slightly different, right? It has to move the head a lot more. But on the other hand, in one step, maybe it can do lots of magical things. So what you have to do is you have to just eyeball the code and have a sense for what the code's doing and tell me 3 lines. You say, no, it's not n squared anymore. It's now into the 4th. Why? Because I got to do this, this, and this. Or maybe you say, no, it's not n squared anymore. Some magic happened, so now it's only n. Or you could say, no, it's still n squared. Look there's this loop and this loop, and this loop loops in time, and this loop loops in time, and maybe there's another loop that loops in time, but both of them are within the one. So look it's clearly n. You just 3 sentences.
But it's definitely going to be slower, right? The running time for the Turing machine.
Definitely is an awfully big word.
But it's still going to be polynomial.
It's still, I will tell you it's going to be polynomial. I'll tell you the answer is somewhere between n and n to the 4th.
Okay, got it.
Any other questions? And you're also gonna have to know how many states there are.
Jeff, on slide 185.
185. Yeah.
Yeah. So on there, I think there's an exit condition, right? And then you go to line 15, and then you move the head as well, right?
Sorry.
Oh, yeah.
Can you start over? I kind of got lost. I'm moving my here. Are we here?
Yeah. So you exit the loop, right? So I'm guessing you put line 15 there because it's after after that line 14 or whatever.
Yeah, exactly.
You're moving the head again, right? I was just confused why you have to necessarily move the head there.
If it's on the blank, exit the loop. So if I'm in line 12 and I'm reading, why did I put it right there? I have absolutely no idea. I don't know. Get rid of it. If you put whatever you want there. I probably, I don't know why. Maybe I cut it and pasted it. I'm going to line 15. You're right. I shouldn't have moved the head. That would be better a stay.
Oh, okay, gotcha. All right, that's all. Thank you.
All righty. Are we good?
While using the delta function, can we put a comparison there? Suppose for insertions for tomorrow,
so the comparison, let's see where the comparison is. Remember my instructions. You need to be filling in a block of the table. And so this is how you fill in an entry of the table. Where do you get a comparison? Well, maybe here I'm remembering that P equals P prime, right? And then over here I say, well, if P is greater than, over here I say, for all C and P prime greater than C, right? This is telling me the range of values for which this is true.
Okay, but what about the other range of values?
Well, you put it in here. You say for this, you tell me what block, each of this line is just telling me how to fill in an entry of the table, right? And so you have to, it has to be like this. But now for different entries, you might do different things. For those entries where P prime is bigger than C, you do this. Here, let's do this.
how can we compare like two variables next to each other while using insertion sort? So I thought we need to put that in every individual line. Like for the addition example, we did it in the video. I wrote the code for Turing machine for it, and I used simply I defined a range of variables for different variables so that s greater than 10, and for all values that are above 10, I can carry one and subtract 10 of it.
Yeah.
Yeah. So how can we do that in this one? I'm quite not getting it. Like I can define it here,
Oh,
you
mean here I had, in that example, I had that s equals this plus this plus this mod 100.
Yeah.
Right?
So
Yeah, well that was,
there?
well, no, you don't want to do that. Because in one in the one case, I might go to a line here. In this case, I'm going to line 15. In this case, I'm going to a line 13. Are those both 15? I can't even read. Here.
That's 13.
That's 15 and that's 13, right?
Yeah.
All right. So my eyes are going, so I can't read my own screen. So let's do this here. Let's put here C prime. All right. So suppose I'm in line 12. Now here are two different cases. In one case.
Okay, I kind of get it. The same we did at the end of this example, we can put two individual cases and then.
Here are two different. Yeah, here are two different cases. The one case is that C is in some range and P prime is bigger than C prime, and the other case is P prime is less than or equal to C prime. And what do we do? Well, if I'm in state 12 and I'm remembering P prime and I'm reading C prime, in this case I moved to line 15, and in this case I moved to line 13.
Yeah, so we are defining the range, but you are also comparing, so we are just putting it with the range and we define it every step.
The comparison's happening in my range.
Yeah.
Here, in this case, P prime has to be bigger than C prime. And in this case, C prime has to be less than or equal to C prime.
Yeah,
right? So those are two different ranges.
Yep.
Right?
Got it. Thanks. Yeah.
Excellent. That was good. That was good. The longer they talk to me, the more you're going to have the answer. Right? That's what I was talking about. Here, that one page over here. I said, right? I'm on this line. There more than be one case. So for each case, figure out what the range is, right? Here,
So
this
that's what I
case.
was confused that where to put that quantifier exactly. So
Yeah,
you
you
just
put
showed me that.
You put this in this range, right? Here I'm saying specify the range that given this case, the case in question, right? So if my case is this, then the range is that P prime has to be less than C. If I'm in the other case, then the range is P prime has to be greater than C.
Perfect. Got it.
Right?
Can we go to the previous example that we just covered?
The same one over here?
Yeah, the same one.
It's here. Why did it pop up there for a second? What's this slide doing? That's a funny slide, eh? Why is it suddenly up there? Yeah, what's your question?
So for this specific example, the running time for the Java equivalent would be linear, right?
Well, no. Let's do the running time for this.
For the Turing machine, there's 13 lines, and then there's two possible values, so there would be 23 or 26 states, right?
Oh, you're counting states or running time? Those are two different issues.
So they're not related at all.
They're not related at all.
Okay. Can we do
Which one do you want to do? Should we do both of them?
Both of them, yeah.
All right. Let's do running time first because I'm on a good page for it.
Okay.
So, what does the code do? It needs, remember, it starts here, and every loop it moves one of the characters over, right?
Yeah.
Right. So, how much time does it take me to go from I to I plus 1? I had to move the head all the way down here, and I had to move it all the way back. How much time does that take me?
It's going to take 2 times the number of bits in between.
Yeah, that's order n, right? Well, because this is of length n. This here is of length 4n. So the whole thing is of length 5n, right? So to travel along, it's going to take me 5n. To travel back, it's going to take me 5n. So that's going to be 10n.
10n.
Right? But I don't care about the 10. I say big O of n, right? Doing that's going to take me order n time. Now, how many I have to, now my I, what does my I do? My I is 0, then 1, 2, 3, 4, all the way up to n. So I have to do that n times. If n times I have to do n, then what's my running time?
N squared.
N squared, exactly. The running time's n squared. Now you're asking how many states are there? Well, if you need the exact number of states, then you can say, how many line 1 states are there? Just one, right? There's just one there, right? How many line 2s are there? Well, there are 2 of them, right? Oh no, there's only one line 2, right? Only one line 2, right? It's just line 2. How many line 3s are there? There's 2 of them. C equals 0, C equals 1, right? So we got line 1, and 2 line 3. So we're up to 4 states so far, right? And now we go up to line, right? There was no line 4, so we didn't have to count that. Line 5 has 2. Line 6, 7, and 8 have 2, right? Line 9 has 2. Line 10 has 1. So we're just counting them. Right? Does that make sense?
Yeah, it makes sense. So generally, would the number of total states be like the 2 possible values for the value we're reading? So there would be 2 values and then
no, suppose on the blackboard here, I'm writing that x has the value between 0 and 9, and y has the value between 0 and 9, right?
Yeah.
How many different things could be written on the blackboard?
10 different values.
No. 10 values of x and 10 values of y.
Oh, 20.
No.
10 times 10 would be 100.
100. There are 10 choices for x and 10 choices for y. So that gives me 100 choices. So if we have here, line 10 has the value of x and has the value of y, then line 10 has 100 states.
For this case, we're remembering the lines, so it's going to be 23 or 13 times 2 different possible values we read.
So if you wanted to just have a quick upper bound, you could say 13 times 2. If you want the exact number, then, well, we skip 4, and they don't all have 2, right? Some of them have 2, and some of them have 1, and some didn't have any. So if you want the exact number, you have to add it up.
On the test, would it be the exact number, or is it going to ask for the upper bound?
I ask the number, and if you gave an upper bound, then I would give you some marks. And if you gave the exact number, I would give you the full marks.
Full marks, exact, okay.
But I wouldn't be, if I was marking it, I wouldn't be too anal. Like if you didn't count the halting state, I wouldn't really care. Right? I mean, it depends on how anal you want to be, right? All right, are we good? I'm going to say, can I go home? But you know what? I'm already home. Not only am I home, I'm in bed. But I'm ready to turn off the screen.
Also, another.
Thank you for the lecture today.
Good, thanks. I hope it was good.
Just a quick
It was
question.
very helpful. Thank you.
Yeah.
Yes, very helpful.
In each Turing machine, is a line number always remembered?
Yeah. You mean yeah. In a Turing machine, the states will always start with the line number.
And it will always remember the lines.
Always, yes. When we get over to the next topic will be DFAs, and they never remember the line. So Turing machines always remember the line. DFAs never remember the line.
Okay, thank you.
Professor, if we get the line number while writing the state wrong, so will we lose marks? Like the statement's totally correct, but we had a confusion in line number.
You guys ask me the hardest. You guys, people always ask me, if I do this, will I lose marks? Well, I'm not even marking it, and I don't even know the context. I say if you got the line number wrong, then that seems pretty serious to me, so you probably lose marks. But I don't know. What am I supposed to do with a question like that?
Actually, I was just writing a Turing machine, and when I compared it with your answer, I had like one line number wrong. So I was like, if that happens in the test.
Right. Well, sometimes it matters and sometimes it doesn't matter. And hopefully the TA will know when it matters and when it doesn't matter. And
when
sometimes
it matters, will I lose the total
quotient? And if it matters, you'll lose marks. If it matters a lot, you'll lose lots of marks. And if it only matters a little, you'll lose a little marks. And if it doesn't matter at all, you should lose no marks. And hopefully the TA can distinguish.
Sir, for the answer, you want it to be equals under, like on the page that you showed us last time with the code, right? Like how you write it, then you put the equal under. You know what I mean? Like I think it was
mod? That mod.
Yeah, I'm just
mod
checking.
100.
Yeah, it's.
We're not doing mod 100 in this example, so you don't need to know anything about mods.
If you go to page 130. You see what I mean, like by how you have to like write the answer. Like, do we make them equal each other like that, like how you made it, like that, or they have to be under each other in the answer?
130. This is 40 still. 1.
Yeah, here.
30.
Yeah, here for. So this is how the structure
This is a real equals, and here we're doing math mod. And yeah, that's a different types of equals. In integers mod 100, 105 equals 5. So if you're doing mod 100, then you need to know that you're in the world mod 100.
Oh, okay.
We're not. Yeah. And the reason mod 100 is good because then your numbers stay within 0 and 99 and they don't blow up. So we're going to do that again when we get to the DFAs. We're going to do some mods, but I will tell you we're not doing mods tomorrow.
Thank you.
Excellent. I think it's time for dinner. I didn't have lunch. Let's have dinner. What am I going to have for dinner? Anybody want to bring me some dinner? I don't have any dinner plans. I'll go snoop around. Or maybe I'll walk across the street and get a chicken shawarma. That's what I often do.
You go Osmos, sir?
Across the street is a place called Lazizas. And they have you're the guy who lives around the corner?
No, I'm not. But I know the restaurant though.
You know Lazizas at Ossington here? It's so good. They give me the best chicken shawarma for $5. And maybe that's what I'll do.
You can also Uber Eats.
I've never Uber ate.
Really?
What's the past tense of Uber eating? Is it Uber ate?
Uber Eats.
No, I live downtown. And I have a bike.
Oh, okay.
Why do I have to pay anybody to bring me food?
Maybe in winter.
I'm really lazy, so I Uber Eats all the
Do
time.
Downtown. I'll tell you, when I come back from Mexico for the next 14 days, I'm going to be in quarantine.
Yeah, Uber Eats.
Right? So Uber Eats, it's going to be Uber Eats the whole way. I'm gonna have to ask you how to do it because I've never done it.
Yeah, I'll tell you. It's my favorite app, honestly. I delete it and then download it again because I'm like, I'm not going to spend more money, but I always download it.
Do you?
Yeah.
Well, I've had, I keep see that? I keep getting fatter and fatter. And one of my things I said at the beginning of the summer is the way I'm going to be less fat is not to always eat at restaurants that are in my block, but to try to eat at restaurants that are 5 blocks away, and then I have to get some exercise.
That's a good idea.
Right, so maybe right now I shouldn't eat at Laziza's. I should walk down the street and find that Mexican place. It's a couple blocks away.
Yeah, Mexican's really good.
All right, are we good?
I think so.
All right, well, I will see you all. Tonight. So tonight I have to post the question, and then you're going to get it tomorrow, and then we're going to talk about it at 2:30, right?
Wait, isn't that for the 1090 course?
Wait, tonight? I thought the questions were at 8 a.m.
Yeah.
I wish you can open them tonight, sir.
Let me restate. Before I go to bed, I tell CrowdMark the questions. And CrowdMark tells you the questions at 8 in the morning.
Okay.
Because you know what I do at 8 in the morning?
Sleep.
Yeah,
I'm
breakfast.
asleep. I'm asleep. I wake up at 10.
Respectable.
Yeah. Well, I stay up late. I'll be staying up late working on the last details of your test, right? So if I go to bed at 2 in the morning, then I'm going to wake up at 10.
Every time you say a test, I don't know, I just get this anxiety feeling. When you say a test, stay up to 2 a.m., that feels like you're doing it well, sir. And when you do it,
hopefully tonight I won't stay up late writing your test because it's already done. I just have to decide whether to give you 1 question or 2 questions.
Well, you're gonna have this shawarma. You're gonna enjoy it. So I hope you don't put that question in.
It's written up already.
I mean, I know, but you still didn't decide fully. So that can't be the case.
Exactly. All right, everybody. Unless somebody hollers, going once, going twice, I'm clicking the button.
Okay. Bye.
Bye.
All right, enjoy your dinner, Jeff.
Thank you. Bye, everybody. Oops. Sometimes this end button is so hard to press. Okay, there it goes.